Kom maar door. Here we go. Hey, Alicia, you're back. Hello. We're we're at the last episode. I'm so sad. I mean, what
Yeah,
about you?
October is my favoriteest month, and being part of October sessions has just been amazing for me. So,
It's been a crazy month, I have to say. We had so many viewers and so many questions. It's unbelievable actually. And I'm happy.
I really enjoyed the session.
Yeah, I really did. Um, I was out last week. I was out sick, but I tried to watch a few pieces of the stream last week, and I was impressed actually by all the people that actually jumped in for me to replace me, but also about the guests that we had. It was pretty cool. Yeah, yeah. So today we're actually talking about advanced AI, but thinking about this episode, setting this up, I actually had sort of a hard time defining what is advanced. And I know you helped me, so maybe you can explain what advanced actually means in this case.
Well, I think that when we talk about AI, there's kind of two components to it. One component is the tech, and one component is to the business processes. And I think that there's a lot of use cases for machine learning and applying the mathematical principles to the data and the technology. But when you apply the principles to enhance business processes and accelerate learning and accelerate triggering of notifications and alerting, that's when your system is said to be achieving that level of AI, that level of independent knowledge and independent learning. So I'm very excited today because we are looking at a couple of systems where we're able to tie together different technologies so that we can help businesses accelerate their learning and accelerate their ability to respond and react to events.
Yeah, yeah, to me that's pretty advanced. I mean, in our first episode, we talked about using cognitive services. That's sort of the beginner level of AI to me. It's very interesting to start with, but it's also just the beginning of AI. And once you get started building AI models, then we should talk about using it in a business process, in a business context, actually. And then you run into a ton of problems um, that might force you to do something more advanced, things like Azure Machine Learning Service and starting to use ML ops for that matter. So that's actually part of our show today. For those tuning in, we're a little bit early. That's on purpose. We're sound checking. We're making sure that we have a lot of fun together and talk about AI. So you're part of our back talk, so to speak. Um, yeah, advanced AI. We've got some interesting stuff coming up around uh, uh, augmented reality, generating office floors. We talked about this before a few episodes ago. And I'm happy to say that we have people who are working on this stuff. And you found those people.
Well,
Thank you.
Willem, it's wonderful working with you because, when we had our session on our custom vision session 2 weeks ago, and we were talking about, well, what is it going to take to make Alicia happy? And you really took that to heart. And you really challenge yourself to figure out, how to find Alicia more window space and more trees to make her happy. And, part of solving that problem is absolutely locating the technology. So I think it's great that, you were supportive in us seeking out a solution to that problem. And so I'm really excited to have Fergus Kid and Jay Natarajan from Avanade here today to talk to us about some of these solutions.
Yeah. And the other advanced topic that we also have this episode is Noelle Silver. She is going to talk about explainability in models. I'm very curious about that. It's all responsible AI, and people may have noticed in the last few episodes that we're very fond of that topic. I think it's important because it helps you prevent certain disasters that you may run into in AI. And today we're going to talk about how do you actually explain this black box of AI. It's pretty advanced stuff, but it's very, very useful to use that in your application. And I should also note, so we have Seth Soares. He's been here before in episode 1. And today he's going to show us deep learning with PyTorch. So building neural networks with PyTorch. And I can hear people groan. That's not very advanced. Well, I asked him specifically to give us an advanced session, and he asked me, is it PhD advanced or pro? Yeah, well, we're going for programmer advanced, but if people have questions for him that are PhD advanced, he's happy to answer those too. So this should be exciting. Exciting episode. We're going out with a bang, so to say. So
I'm so excited for today's session.
Yeah, shall we get started for real? I mean, it's 7 o'clock, so it's time to run our first guest. People are holding up pieces of paper, interpreters, and so Alicia, you mentioned that you have Fergus on the show and Jay. Can you maybe introduce them to us? They're colleagues of yours, so yeah, let's see what they've got.
Hi, so good afternoon and welcome to Jay and to Fergus. So Jay is one of our executive leaders in data and AI. I believe is data and AI as part of the North America region. And Fergus is part of Avanad's COE. So that's our Center of Excellence program. And he gets to work on all the fun stuff. Like when I'm reincarnated, I want to be reincarnated as Fergus because they give him, like, you want to talk about the kid with the coolest tools or the coolest toys. That is Fergus. They let him play with the latest and greatest. And I'm so grateful that he's accepted our offer to speak today, and I'm happy to welcome him into the community. And I look forward to hearing more from both of you. So welcome.
Cool.
Thanks, great to be here.
Yeah. So if people have questions, and I bet they will have about this topic, feel free to tweet to us, ask them in the live chat. We have a live chat on our website, and we'll get them to the speakers tonight. I should also note, if you're interested in winning a $50 gift card, we're giving one away, the last one of the series. So you can win one if you tweet to us using the hashtag #C#Corner and the hashtag Global AI Community. And be sure to fill out the form that we're posting in the live chat so we know you've tweeted and we don't have to search old Twitter for tweets. And you can make a chance, and we'll announce the winner at the end of the show. So that's good to know. Yeah, take it away, Fergus.
Awesome. So yeah, I'll start off by introducing Jay, who's going to talk us through the first couple of slides. So over to you, Jay.
All right, thank you. It's a pleasure to be here, and thank you all for joining us today. As Alicia introduced me, I'm Jay Natarajan, and I lead the data and AI for West Region for Avanade. And prior to Avanade, I spent about 12 years in Microsoft. So it is awesome to be here. And as we are thinking about data and AI, as you all know, with the pandemic and with the technology shift that we are seeing, we are slowly coming to realization that the technology shift that we are seeing is going to be permanent. In a lot of customer conversations, when I go in, most companies, and we start talking about some of these technologies and how can you derive insight using data, and how can you actually go from descriptive to predictive to prescriptive analytics, most companies are asking, is this technology new? And how do we explore the art of the possible? So that is on one side. And if we look at the organizations in general, they're slowly recognizing the white spaces and the blind spots, and they want to do something about how they can operate in this new world. all the talents are right now disconnected, and you can actually live anywhere and you can work from anywhere as well. So as long as you're technically savvy, the opportunities are actually endless. Even with all the talents that are available and all the resources that are available, think about the advancements that we have in hardware, algorithms, and data, and everything that came with the fourth industrial revolution. A lot of organizations that we work with do not still use the data to actually make the decisions. This was one of the statistics that I was reading a while ago, and I forget where I actually read this, but the statistics go something like this. Actually, 1 in 3 business leaders make critical decisions without the information they actually need. And even when the decision makers are making decisions, they first lean into a personal experience, then they use analytics, and lastly, they go to a collective experience before they make a decision. And you may actually be wondering, why am I talking about this? This becomes very important because you need to have the data for you to make the right decisions, for you to predict how can you actually use technology to make the decisions that you want to make. So actually gathering the data, collecting it, and storing it in a cloud, or storing it in a location where you have an ability to scale, is going to become super important for organizations to leapfrog into this new world. On the same topic, as you all know, when the COVID actually started, we all knew that, we have to have the right data, and the AI would help us to analyze the data better so that we can get to the right outcome. However, COVID taught us a very important lessons on the importance of data and why interpreting the data across the whole value chain becomes important. Because when the reports and everything started to come out, nobody was on the same page. None of the analysis actually matched. And that is because the data was inconsistent, and not all the data was actually available. And most of the cities were actually dealing with digitizing the data. And once the data was digitized, it needed to be cleaned and governed and everything before you can actually have any kind of insights derived from that data. On the flip side of it, we had a real need for how can we use this technology to make people safer. For example, when the CDC started mandating that, hey, they didn't mandate, they were recommending that you need to be 6 feet apart when you were in a public space. It became important that how do we actually measure? We can use the cameras, we can use the technology that was available to make it smart and understand, are people following the guidelines that CDC is actually placing, so that we can get the workers back to the work safely and securely as well. So those are some of the areas where we started mixing the technology. We can actually look at the cameras and we can see the data that we get from the cameras and see, are people actually 6 feet apart or not? If they're not, how can we put some guidance around it to make sure that people are standing safely? So this is a very, very simple use case that I'm talking about. How can we actually how can we leverage the smart spaces, and how can we really have a huge impact on our life? Because whenever we talk about AI or mixed reality, extended reality, however you want to phrase it as, some of them are very visible. If you look at the autonomous vehicle, it's very, very visible on how technology actually helps you. But a lot of these smart spaces, the technology that are used in the smart spaces, are very less apparent. But they're very capable, they're very efficient, and they're very necessary services that is going to help us transform our lives as well. So with that, we can go to the next slide. So I just want you to leave with the one thought before I transition to Fergus. AI is going to impact your business, and that is very, very certain. And it's actually up to us to decide how are we going to adapt, meaning how are we going to skill up. You can look at healthcare as one of the industries where AI is actually transforming people's lives. That's one area. Manufacturing and even construction is becoming one of the industries where AI is being adopted much faster. So, so for us to be in the business, or for us to transform our reality, we need to actually redefine how AI is going to help us do things differently, and how it is going to help us do different things as well. Meaning, how can we leave some of the mundane tasks to AI so that we can move to a much productive challenges. So with that, I'm going to leave it to Fergus, transition to Fergus, so that he can start showcasing some of the awesome work that we did around smart spaces. Fergus?
Great, thanks so much, Jay. And thanks, Alicia, for the epic introduction. So my name is Fergus Kidd. I am one of the emerging technology engineers at Avanade, based in London. So the emerging technology team at Avanade looks at a really broad range of technologies that we think are sort of coming up and are of interest and importance to our clients in the near future. So we look at everything from quantum computing, as you see on the left, physical robots and in our physical spaces research, 5G, next generation AI, all sorts of different topics. So I do have one of the cooler jobs in Avanade. I would be the first person to admit that for sure. So what I want to talk to you today is I want to introduce a couple of technical topics, just in case you're not familiar with those, and just define them in the way that we do here at Avanade. I want to talk briefly through what we're actually doing with those technology, and then give you a demo of what we've actually done so far, what that looks like, and what the kind of results are around this idea of like physical spaces and extended reality. So the first thing, it will make a little bit more sense as we go through why I'm talking about digital twins. But firstly, I'm just going to go through what a digital twin is. So digital twin is a virtual replica of a physical entity. It could be anything. It could be your car, it could be your mobile phone, anything physical, small, large, complex. And included in the digital twin is, first off, a data model. So today we're going to talk about smart spaces. So the digital twins that we're going to talk about are for buildings and spaces. So the data may be IoT data from sensors in rooms or spaces. It may be data about the room itself, the dimensions, how many people can fit in there, what sort of furniture it's got there. The digital twin also includes a whole host of analytics and algorithms. So all sorts of artificial intelligence going on there. That's probably a whole nother talk about what we can do specifically with smart spaces data from the digital twin. And then also crucially, we have that control element. So we're able to make decisions and actually actuate those as well. So, you know, in a smart building example, it might be, this room's too cold, let's turn on the heaters, and we can actually make those decisions within the digital twin. So why would we use one over other data models and other ways of doing things? We really want to use them when we're closely aligning a physical and digital world. So when the digital world needs to represent the physical world in a very close fashion, or maybe needs to be almost real-time and live data, we may not need it in a situation where there's a static physical object that doesn't change a lot, or we don't really we want to see it over time, or we don't want to see it necessarily in its live state. The other reason is because it helps collaboration between stakeholders, especially with difficult and large problems. We often have lots of different stakeholders involved, and you can imagine with a smart building or a smart space, there's lots of different people. So there might be people trying to book space. There might be people trying to control the atmosphere, the temperature. There might be other people more interested in how many people are using the space. Is social distancing being adhered to? Lots of different stakeholders. And also it just helps us integrate and abstract those underlying systems. So really taking all of those different systems, different building systems, and integrating them together in one coherent place where we can get the most out of all of that data. Next, I'm going to talk briefly about what is XR. So we all know that we throw a lot of algorithms around in our daily life. Not algorithms, sorry, acronyms. So I just wanted to demystify a couple of these that I might be using. So what's the difference between augmented, virtual, and mixed reality? So augmented reality, the example we have here is Pokemon Go. So some of you might be familiar with Pokemon Go. It's an app on your phone, a game where you can use the camera to see Pokemon appear in your real environment. So it's using the real physical environment around you live and adding to it. Virtual reality is an entirely virtual environment that we place ourselves into. So we're not looking at anything real when we're in VR. We're looking at entirely generated content. And then there's MR, or mixed reality, which is a kind of a combination of the first two. So we're using elements of real objects, we're using elements of virtual objects, and then interacting them together. So really interesting. We use the term XR, or extended reality, to actually come as a combination of these technologies. So when we say XR, we may actually be talking about AR, VR, or mixed reality. And this piece of research comes into what we call at Avanade our experiences without boundaries research. So you can go to the website and look this up and have a further read if you are interested. So what are the benefits of using XR? First one is one that comes up quite a lot is immersive learning. So having people gain skills in a sort of realistic setting without necessarily using expensive equipment or even dangerous equipment. So safety is another huge factor. We see a lot of applications of XR in manufacturing, in mining, in dangerous and high-risk scenarios, so that we can mitigate the danger away from those users who may be doing something for the first time, who may be still in that immersive learning stage, and make that safer for them. Also, we can personalize these spaces to use whatever we want, so it's much more personalizable. Microsoft's really been at the forefront of some of this technology. This is an example of the Microsoft's Hololens being used to allow a father and a daughter to interact in the same virtual space, even though they're in physical spaces, separate physical spaces. So, they can interact together, they can see each other, hear each other, and in the same virtual space, even though they're in different physical spaces. So the question we kind of asked ourselves, and the story that I want to tell you through a series of short demos and showing you what we've been building, is how can we use extended reality to connect distributed teams and formal physical workplaces? So a lot of us are now working in different places than we thought we would be at the beginning of the year. We're working at home, we're working with people all across the globe, potentially, in our organizations, and we're outside of those former workplaces. So the idea behind this was, how do we use some of this technology to not go back to the office, but look at different ways of thinking about using physical spaces again. So I wanted to go through some demos, and I'm going to kind of walk you through the process of how we get from digital twins to extended reality and everything that's involved. So the first thing I want to show you is actually not that, is this. So this is a very complicated architectural diagram of a physical space. So this is an Accenture building that's still being built in Manhattan, in Midtown in Manhattan. And this is an architectural diagram. So this contains all of the information about the physical space in terms of the layout, the furniture, what facilities are available. So you can see here we have a coffee point, a kitchenette, restrooms, a reception area, all sorts of different information. But this is useful for if you were in construction, putting the building together, but that's about it. So what Microsoft have been working on, and we have been utilizing at Avanade, is the Azure Indoor Maps. So Indoor Maps is a new part of Bing Maps, soon to be Azure Maps, which allows you to map and generate your own indoor spaces as part of Bing Maps. So this could be a campus, a single building, a section of a building, anything you'd like. And you can see here that we've actually used algorithms provided by Microsoft to go from that quite technical architectural drawing to this quite nice, familiar looking map. So we've taken off a lot of the excess information and we've overlaid our own using Microsoft's APIs. So in this case, we're looking at occupancy. So we have IoT sensors on every desk and in every meeting room. We have information in the digital twin about how the rooms have been booked. We also have those sensors which allow us to paint a picture of how the space is being used. So this is just some sample data because this building hasn't been built yet. But for example, in this bank of desks, I can see that 3 of those are actually booked out and in use. This orange one here might be booked out, but it is somebody's actually sat there, but it's not booked out. And then the green ones may be, okay, that room is actually, there's nobody sat there at the moment. The sensor's coming back saying it's empty and it hasn't been booked. So this is immediately available. And I can look at this and very quickly say, okay, these are the desks I can get, are available. This is the meeting rooms that are available. And then we can start doing other things like wayfinding. So how do I get from reception? Maybe I need to go up a floor. Maybe I need to go down a floor to find the space that I'm looking at. And this idea then led to a discussion on visualizations. So this is a very sort of familiar way of visualizing a physical space. You know, most of us who are familiar with looking at maps regularly will look at this and say, oh, okay, I kind of understand what's a wall, what's a desk, what's a piece of glass. But then we started asking ourselves, in this particular example, this building hasn't actually been built yet. So what is it actually going to look like? How can we make users more familiar with the space if they have never been there before and they don't know what it looks like? So then we started thinking about changing this from a 2D perspective into a 3D map. So maybe we could get more information about the layout of the building. So what we were able to do using the APIs available within Azure Maps was actually generate this 3D model of the building. So this is the same information, and we're able to automatically generate from our map, which is our sort of data source, the same meeting rooms, the locations of the desks. We're able to import automatically a model of a desk and put it where the desks appear in real life. For example, we can see the meeting rooms. We can even visualize where the glass walls are as opposed to the solid walls. And so we can get a real idea of this space, what it looks like, how we might use it. And that's all completely generated automatically, just simply from that step process of going from the architectural diagrams to the 2D Azure map to this 3D model. But then, okay, this is okay. We can see the walls, I can see the desks, I can see the units. But and this is great for visualizing the desk occupancy. So on this 3D map, I can kind of get an understanding of the space, and I can see which desks are occupied or not occupied. But then we need to start. Then we started thinking, well, how can we then actually improve this so that we can walk around the space, explore the space, imagine, see what it's like? And that also has, you know, this all has implications with the COVID pandemic. We can use this for physical distancing, but we could also use it for actually linking up with our colleagues and using and interacting in digital spaces as well. So after we got to this point, we started experimenting with, but this is just an example of how we actually use the 2D information. So we are looking at desk occupancy, things like temperature, air quality, lots and lots of different pieces of data. And this is how, just an idea of how we would visualize that. So in a traditional portal, in a 2D sense. But now we're kind of taking that to what do we do for a 3D environment, or one that we can use. So in exactly the same way, one of the amazing things that Azure Maps will have the ability to do at some point in the future is actually not require those architectural diagrams, but be able to go from images of floor maps using AI to generate the same 2D spaces on 2D representation of the spaces. Then we can actually go from the 2D to the 3D using tools like Unity. And then we can augment those once we have the layouts and the plans of the building with furniture assets, colors, and textures that we would expect to see in the building. So for this example, I'm actually going to change the building perspective and go through an example of our London office instead of the Accenture New York office. And this is just because I'm more familiar with this space. So I'm currently sat in that digital space using a rendering because I know what it looks like and I could more easily model that effectively. So here's a couple of images. On the left, you can see that there's a real image of the space versus the virtual image of the space. And this particular picture actually kicked off a something for us, which is once we had the walls and the desks automatically generated, and I started adding personalized hand-built features like the windows and the stripe on the ceiling, for example, we then got the feedback that this space is very empty. It feels unused. It looks too clean. The real offices are always, cluttered with stationery, laptops, people's, personal effects, as you can see on that image in the left. So what we started doing was actually using procedural generation. So we have imported a bunch of different assets like computer monitors, keyboards, and desk clutter. So there's some mugs and some coffee cups, and we know where the desks are from the information in the 2D maps. So we can add the sort of desk clutter and make it feel more lived in. We can also add other pieces of furniture from that map once we have an idea. And once we can import objects easily, we can just sort of place them around to give a more accurate representation of that physical space. So here's just another rendering of what that space looks like, rendered in Blender, so it's quite shiny and polished and nice. What I want to show you next is actually a video of us using the space in a Oculus headset using a tool called AltSpace VR. So this is the same space, but rendered on a headset, so it's a little bit lighter. We've lost some of the nice textures, but we still get a really good idea of the space. So in this case, we can use the headset. So I have one here. We can wear those and we can explore the space in the sort of 3D digital environment and world. And we can move around that space. We can collaborate with other people. So we can also install bespoke tools into those spaces. So for example, here we're watching a video presentation with my colleague Christy, whose avatar is there. We can also fiddle around with interactable objects in those spaces. So this is us trying to play very badly catch, because neither of us are very coordinated. And we can use the space in sort of any way we want in that sort of interactable way. We can also use custom pieces of code. So this is us playing a quiz together, take selfies, lots of fun things to do in VR. So it does seem like some fun on the surface, but actually there's very real applications to this, remote, working remotely together. We can do sort of design thinking workshops. We can do lots of the tasks that are difficult to do around 3D modeling, sharing information on 3D objects, and really exploring different techniques. We can also do virtual tours. So this is actually me showing my colleague Christy, who's from the Seattle office and has never been to the London office, showing her the boardroom, for example, of that chemistry office. So I wanted to use an example as well of why AI is so important and why procedural generation is so important when we're thinking about virtual spaces. The example that jumped into my mind was to look at all of the work that Black Shark AI have done with Microsoft Flight Simulator. It's a really good example of procedural generation on an absolutely enormous scale. So looking here, this is actually, if I can use my pointer, on the left, we can actually see St. Paul's Cathedral in London, and the, that's not that clear, but maybe I can use the pen. No, okay, sorry. So that's actually the building Microsoft had no information about what the building looks like other than its shape as seen from space, but we've managed to create these really realistically looking environments for the flight simulator platform. And on the right, we have the One Manhattan West location. So that's the first building I showed you, but you can see it hasn't been built there yet in that photo. So it's still that ground piece. But what we can do is, using all this AI and procedural generation, is make these amazing environments with quite a lot of time and effort. So Black Shark spent a lot of time and there was a lot of investment in this absolutely massive project to 3D model the entire world. But the key point for me on this is that it's actually some procedural generation. So, for example, the buildings on the left are just generic buildings, apart from St. Paul's Cathedral, and some bespoke handmade items to bring that realism. So St. Paul's Cathedral has been hand modeled by somebody. Or some of the buildings on the New York skyline have been hand modeled. So it's really a blend of using the AI, the procedural generation, the automatic techniques, and a little bit of human creativity. And to be honest, it's a bit of a labor of love as well to create some of these 3D digital spaces. So with that, I will say thank you, and I'll hand back to Alicia for the panel session.
Cool.
Thank you, Fergus.
Yeah, that was interesting. I never realized that the stuff that they used in Flight Simulator is actually usable on inside spaces as well. So that's cool. Huh.
Yeah, definitely. All the techniques and all of the AI and all the procedural generation is, as long as we're it's all, for me, it's all about the data, right? So they started from having big maps, which is a huge asset for Microsoft to be able to generate those 3D spaces. We're starting from either architectural diagrams or image layouts of buildings.
Yeah, cool. So we do have a question from the audience. You've shown a lot of stuff, actually. You've combined IoT with virtual reality. There's definitely a lot of software engineering going into this. And then there's the AI, I guess, for the object generation. How can you explain a bit more how the procedural generation works, especially since you've also got these fixed assets in your scene?
Yeah, so it's kind of a combination of techniques, really. There's a lot of artificial intelligence in going from that data product, which is quite complex, unstructured data, to something that we can actually understand in sort of a structured data format. So when we go, for example, from the architectural diagram into the 2D Azure map, there's a lot of assumptions that have to be made by AI systems about what certain objects are, where certain rooms will go, especially if we're looking at using the future capability of going from a flat PNG image. We have to actually work out what is in the image, what are we actually looking at, and what those assets relate to. And then there's kind of the procedural generation part, which is a little bit more traditional, of just sort of number crunching. Okay, well, I know where the desk is to start with. I know where the wall is, so therefore I know where to put computers. I know where to put chairs, and we can just automatically sort of run through that generation as well and build that up. In some of the more complex scenarios, there's also a lot of intelligence required to actually map textures, especially in the flight simulator example. There's a huge amount of knowledge needed to make. If you start with a basic rectangle, which represents, say, a structure, you have to know what sort of materials would look okay on that, whether, how many windows to use, all sorts of different information. So there's a lot of different techniques in there, depending on your goal, I would say.
Cool. So the other question that people have is, in the Microsoft example, there's a lot of data that you can use. I know for a fact that Azure Maps has all of these different combinations of information, for example, satellite data, geographic data, buildings, all that stuff. But what happens if you don't have so much data to generate these extra objects in an indoor space? I can imagine in the
Yeah, well,
case of Avanade, you don't have a mountain of data, but you have a small pile of data to work with.
Well, that's absolutely fair, but I mean, it's the sort of Achilles heel of data and AI is we need more data. Always, we need more data. So I think what Microsoft have done behind the scenes and are continuing to try and do their work going forward is make it as accessible as possible depending on the data type. So we're not dependent on a specific format of architectural drawing. We're not dependent on any specific satellite data. We can just use the data that is available to us. If at the end of the day, when the service is released, that means you're just drawing boxes in an architectural plan and saying, okay, well, I measured it. You can add the data that way, but obviously we're in a much stronger position if we start off from a position with good and reliable data.
So Alicia, we're going back to the conversation that we had a few weeks ago. You wanted more windows, and there was something with a beach. So
I'm thinking about it, and when you look at the applications, if the floor plan is known, like, is there now a future where I can put on a headset and reskin my work environment? So you can put me in the warehouse, or you can put me in the basement, and I can go ahead and paint the walls bright pink if I want, and my cubicle partner can paint the walls, black and gray if they want. And maybe there's some reskinning that we can do for our environment. So,
yeah, that's a great idea.
Yeah. Then, if they could just tie that to the sensation of, jumping into the water, then I would be set, right?
Yeah. I mean, if we could bring this down from architectural drawings and a lot of complicated technical stuff down to a PNG, I can draw a PNG in Paint. I mean, just draw a few lines and we're good. We're set. We can design an office, I guess. Or does it take more than that, actually?
Well, on the sort of base level, no. If you have that basic drawing, we can give you a basic building, and once your building once your virtual environment is set up, then depending on the exact tools you're using, you can just go in either to Unity. So in the Unity example, you could just drag and drop colors onto individual walls. So for example, behind me this way, there's a yellow wall. If we wanted to change that pink, I could just go into Unity and drag a pink color and personalize that. So they can be personalized. Again, if it's a shared virtual reality space, then we probably have to think about the other people. But if it's our own version of the office, and that's the great thing about the sort of personalization part, is we can do whatever we want. The other thing is we can actually, using the headset, we can drag in tools, collaboration tools. We can drag in video players. We can drag in games to play together in VR. As well as like customizing our environment in the way it looks, we can actually customize it in the way that we can interact with it, which is really, really cool.
So today we have joining us Anthony Bartolo from Microsoft. And Anthony, how are you? Thank you for joining us. And we're going to have him check his sound really quickly. But Anthony does a lot of great work integrating drones and HoloLens and solves some similar problems for users. So I'd love to hear Anthony's input in how the applications for this technology and some of these problems that are being solved.
Well, actually, I'd like to discuss a little bit further in terms of this solution, because what I love about it is it addresses an opportunity. Too many times we've seen organizations go forward and say, how do I adopt this new technology and add it to something? Instead of, how do I address a problem or an opportunity leveraging technology, but not having technology being the main purpose as to why the adoption is occurring? What I loved about the demonstration that was just delivered was the proper use of office space in terms of interacting with employees. There's a need for increase of engagement. There is a need for increase of playfulness amongst coworkers, and so that instance and that capability that was highlighted was done in such an awesome way, in the fact that it highlights how technology uplifts the opportunity or problem that needs to be addressed, as opposed to being the main cornerstone behind it.
So I know you've been working on a project in the search and rescue area. I can imagine that it would be useful if you wanted to build a search and rescue drone to have a sort of a 3D image of the environment that the drone is flying in. Is that something that you actually tried in your solution? I mean, people will get to introduce the solution itself later on, so this might be a bit unclear to them, but I'm curious, how can you actually use 2D maps for controlling drones in this case?
And that's an interesting premise, right, behind what can be accomplished. Back when this proof of concept was actually initialized, this whole aspect of spatial mapping wasn't available. The technology didn't exist in respect to understanding the surrounding areas. The drone itself was taught to pinpoint a specific instance or issue, which is in essence the life jacket inside of on the water. To fly to that location, the requirement was such that it was, given the coordinates to the drone would specifically fly to that geographical coordinate, the GPS coordinates that was given to it, and then once there, assess the situation or the area, right? Even to that respect, what was done to make that happen was based on the opportunity, not on the technology. The technology, in terms of custom vision, as an example, didn't even exist in its current form. And so when we built out this model, it had to be on need of the solution that we were trying to address, not how do we incorporate this to make this better, right? So it was an interesting premise in terms of how we understand how technology is leveraged to address opportunities and problems, as opposed to adding it for the sake of adding it. But definitely, in the spatial mapping sense, had the technology been available for the proof of concept, 100% it would have been a huge advantage. More so from a further automation of the drone flying itself.
Yeah, it sounds really interesting. So Fergus, I was wondering, how did you actually start this project? Did you start from a technology perspective, in a sense that you wanted to use emergent technologies and then you found a problem, or did you start from the problem? I'm really interested in how does a project like this come to be?
Yeah, that's a really great question, actually. So the project came to be because we were building a new space and we had an opportunity to start from scratch. And Accenture thought, okay, let's do this right in the right way. Let's build a building that represents our technological capabilities, our partnership with Microsoft as well as other vendors and suppliers, and really shows off the future of work. So that's kind of how the project came about. It was more putting people first than technology and making sure that these spaces were accessible, usable, and using technology to make that happen. So really we went about choosing the best technologies to fit that particular need. Obviously, a few months into that, the pandemic hits and things start to change a little bit, and then we start asking ourselves, actually, the technologies that we're using in the solution that we're building can actually be used further. So it sort of evolved as we went on, and that's the great part of working in a research team is you're slightly flexible to explore those new ideas and build new assets and do some of that development. But really, it came from a sort of a people opportunity first.
Yeah. Nice. Alicia, I guess that so we've talked about our beach thing. I was thinking maybe we could do a virtual reality flyby in a drone or something, maybe control it from our VR set. Is that a far-fetched idea once we have this combination of technologies, or how does that work, Anthony?
Oh, Anthony or Alicia? I thought you were talking to Alicia.
Sorry.
Sorry, my head is in the clouds. I just booked my tickets to Hawaii this week, so no serious talk for me.
So my background is actually Maltese, and I haven't been back to Malta since 2000. And one thing I was thinking about in terms of the whole project that we did with the drone was in the inclusion of spatial mapping and tools like, you know, the flight simulator piece in terms of the mapping of the geos and understanding of your space. How far are we from walking on the beach virtually via our headsets and having in our place on Rumla Bay, as an example, in Gozo, the ability to walk down the beach? Aside from touch, you know, even smell right now can be simulated in terms of, you know, the devices that we have and smelling of the salt water and the sand and what have you, right? So, you know, we're not that far away. The technology exists. It's just the problem itself or the opportunity has to be solved, right? So you know, it all is based on our imagination and our creativity, but doing so in such a way that we're addressing that problem or opportunity, not just rubbing technology on it and hope that it's going to make something really cool.
Yeah. So, especially given the whole COVID situation, I'm thinking that this could be very, very useful. So Alicia and I have been joking around about this stuff for days, actually. Every time I speak to her on Slack, on Teams or other online tools, we keep getting back to this idea, having virtual reality and AI combined, and generating a space where you can get outside during a lockdown. That sounds really, for some people, it might actually be life-saving. I know from a couple of friends that they can feel pretty locked up these days, and it can have severe psychological impact on them. So I'm thinking, yeah, this could be actually a tool, not only just for fun, like Alicia and I have been joking about it, but actually for real, and that makes it really interesting, especially in this day and age. So and this is a question for both of you, Anthony and Fergus, what do you think is the most important piece of technology that you got that made you decide that this project is feasible? Anthony, any thoughts?
So this is the thing, right? When we did the drone project for on behalf of the Canadian Coast Guard with partner Indro Robotics out of Vancouver, the technology didn't exist, right? What we were asked to do was the drones that were flying out to sea were man controlled or operator controlled, sorry, and you had this drone that would go out and survey the area and then film and then fly back. The initial ask that had come to Microsoft was, we need you to help us with a compression agent to compress the video stream, because right now there is no connectivity for these drones that's flying out there, and we have to wait till the drone comes back into the central office to review the tape and to do the analytics on what the situation is, so that we can send out rescue equipment out there to save these people. And in saving a life, every second counts. And so when we looked at this and we looked at the opportunity, like I said, computer vision wasn't even launched yet. It was still in its infancy in terms of what Microsoft was testing with. And we, thankfully made a connection with the engineers here at Microsoft to allow us to run this test and run this functionality to address this opportunity to see if it was even feasible. What's been amazing is the amount of growth that has occurred from custom vision from the perspective of the initial thought was, just recognizing objects. There was no thought of a moving object recognizing objects, or, let alone understanding what objects look like on the edge without connectivity, right? We talk about edge computing today. The proof of concept that we started out with the drone project was 4 years ago. So the way the technology moves so fast and so quickly, I love the fact that technology is adapting to what our needs are, as opposed to organizations dictating where technology is to go.
Yeah.
And I would absolutely echo that as well. I think, for us, it was really a combination of technologies. The IoT devices, the cloud infrastructure has been there for a while, but the whole combination of integrating that with a familiar visualization platform in the 2D maps is really only over the last year or so. And it's just a sort of combination of all the different technologies, as well as the technologies themselves being more available. So VR headsets are coming down in price. They're getting newer versions which are lighter. You can use your mobile phone in a cardboard frame to access some of these these functionalities and these features. So the entry cost is coming down, which makes it more accessible. In terms of your question around like how engaging it is and things, I think one thing we were looking at, which is quite interesting during our testing, was the sense of physical proximity and how important that was to actually feeling like you're using space together and using objects and items in the physical space together. So I think we're all quite familiar with Teams calls and Zoom calls, and for our socializing these days, since it's more difficult to get out of the house. But the addition of extended reality allows you to actually get that physical sense of presence. So if I sort of move my hand sharply at the camera, very few of you at home are going to react. But if we're together in extended reality and I move my hand very sharply at your face, you're probably going to recoil and move back because your brain actually sort of processes the information differently.
Yeah. So Alicia, this is an interesting question for you. I know you've got an Oculus Quest at home. Have you tried any of the other devices, so like the one we just mentioned, the cardboard box in your mobile phone in that?
I haven't yet.
So what sort of experience do you get from the device that you have currently, the Oculus Quest? How's that for you? This is actually a giveaway item from one of our last sessions. So I haven't opened the box. I've been really good. I've been dying to open the box. It's an open present that's sitting in my office right now. But Anthony and Fergus, if you had any feedback on devices out there.
Well, I've got a barrage of devices behind me. I don't know if you've seen my shelves. I've been very lucky to have a lot of toys to play with. The biggest and most impactful devices that I see are the ones that are readily accessible to the general masses. I've been, very lucky to have the opportunity to work at Microsoft and have access to a Hololens. I have a Hololens Gen 1. I don't have a Gen 2 that I get to play with. And while it's really cool, you understand that, the availability of a device like that at $4,000 to $5,000, it's an expensive device. That's Canadian. I don't know what the transition would be into US or other currencies. The big thing is the cardboard box and the availability that, I've been to elementary schools here and have shared the cardboard box idea with Minecraft. And the kids all have phones, like iPhone 6, Galaxy S4s, phones that are 4 or 5 years old. And having the ability to understand and utilize a device in another way that they don't know is available to them. Using, you use the Minecraft world technology, and they're now building structures inside of their classroom, and they make it functional. And the teachers invite them to, hey, build out the study area using Minecraft. And so there's that type of interaction. And you see their eyes light up and go, wow, that's amazing. The likelihood of each student getting a HoloLens, I would love to see that, but it's very difficult. The availability of the cardboard box makes it, on a level playing field in terms of ideas and enablement, with the hopes that, down the road they reinvent what services Microsoft need to create.
Yeah, and I was thinking, you mentioned Minecraft. So if people decide to take this on, this sort of a project, procedural generation of stuff in a space, what would you say is a good environment to start using AI in that case?
I would actually, before even dabbling in an environment, I would actually fully map out what are you trying to address. I think the technology follows suit in regards to what devices you have at your disposal or what services you have at your disposal. I think that's what, obviously being comfortable with a specific platform or technology is also going to be very important in terms of your adoption. But starting in terms of understanding where the problem exists first, or the opportunity exists first in terms of what needs to be addressed, and really detailing that out. I can't stress that enough, because I've seen it time and time again where people will lead with technology, or organizations will lead with technology, and they'll go down the route and make this huge investment in terms of adoption of said technology, not thinking about the limitations that may occur in terms of devices, availability of services, on and on, right? And then being stopped midway or having to change their requirements to a lesser requirement because they can't move forward unless they do so, missing out on part of the opportunity, right? I think if you're talking about platform and enablement and language to code into, a lot of the projects that we build in such a way that they're malleable. You can use them on any platform, and that's why I love showcasing the drone solution, because it's evolved into so many things. And I'll be honest, like the drone solution itself came from an accident in terms of myself connecting a Raspberry Pi to a mousetrap and understanding the travel patterns of mice inside of warehouses. And that was from an IoT experiment to see if we can even catch more mice doing that. And the learning capability that came out of that in terms of machine learning, it just blew my mind. And then that opened, like, that's the thing. It's the ability to play, the ability to understand the opportunity, the ability to grow from that, but doing so with what you have at your disposal. Not worrying about, I have to go out and buy this $5,000 unit or else the solution is not going to work. Never limit yourself by that, right? You're always able to move forward in terms of your idea as long as you understand what your idea is and what you have at your disposal and what you can create. And you can still go out and ask and say, are these services ever going to be available? Is this something, the community, like, so important, like, this community here, in terms of everybody that's participating online, everybody has an idea, everybody has a device or a service that they can bring into the fold and share, knowledge being made available to everybody to move forward with. Huge opportunities in terms of growth, in terms of creation, in terms of, addressing opportunities as a whole.
Yeah, what about you, Fergus? Any recommendations for people how to approach such a complex project as you've worked on?
I would say, to echo Anthony, you've got to look at the end goal and then sort of decide what the best technology and the best approach for you is. And, just keep everything as agile as possible. That's the best advice I can give you, is like, make things in small iterations. You don't have to start big. You don't, even if you have grand ambitions for a 3D visual space, just download Unity and put a cube in there and, have an explore of your cube, and then build up both your skills and your assets as you go. And so don't be afraid to jump in and dive in. In terms of technology, again, agree that the more and more accessible this becomes, the easier it's going to be. I mean, if you went back to the 1980s and said, every child's going to be required to have access to a computer to attend school one day, they would have thought you were mad, because powerful computers were the size of rooms, and people just didn't have an ability to afford that. So as these things come down in price, it's going to be so much more accessible and so much easier to get started with. But crucially, on the flip side, is that we're going to need the skills and the people to develop the new applications in the new environments as well. So I'd say, get learning, get playing.
Yeah, and speaking of good resources to learn and play, any recommendations for people, maybe websites they can go to, or books they can read to learn to work in a 3D space using virtual reality and AI, and or flying a drone for that matter? Anthony, any ideas?
Actually, I think he was going to say him first. He's got something to share, I think.
Sure, I was just going to say, like, there's tons of courses that you can pay for online, which are pretty good, but actually YouTube is a great starting place. There's tons of like bite-sized tutorials on YouTube that I've used for both Unity and Blender. These are free software. These are free pieces of software when you're using them for the first time, or you're not using them in like a professional context. So download the tools, have a go, look at some YouTube videos and get started. Especially for Blender and Unity, some of them are really nice bite-sized chunks, which you can learn to do like one or two things step by step, and then you start getting an idea and you can sort of go on. And then once you're ready, I would say just challenge yourself, come up with an idea of something you would like to 3D model or an environment that you'd like to create, and have a go. Start basic and have a go. In terms of flying drones, I have some limited experience with that, but I would say invest in a drone that can fly itself if you are not as coordinated as I am, or no, as uncoordinated as I am. I've definitely crashed a couple of them.
Cool.
Actually, all the ones behind me are broken. That's why they're up there.
How many drones did you break, Anthony?
Oh, too many. My drones are now made of foam, so they don't break. I echo in terms of the YouTube and the videos that are available online. I like to get my hands dirty. I like to play directly in environments. There is, sometimes the cost that you have to adhere to in regards to that. Microsoft has a phenomenal solution called Microsoft Learn. I believe it's microsoft.com/learn. They've invoked what we call sandbox technology, which allows you at no cost to dabble in Azure environments to build out solutions and test out theories, and it provides you step-by-step instruction to do so. I do know that there are some augmented reality Learn modules that are out there, and if there's a specific module that is for a requirement for yourself in terms of upskilling is not there, let me know. I'm directly tuned in with the MS Learn team, and we're actively building out new modules as we speak based on your requirements, based on your audience's requirements in terms of what they would like to see further learnings on or interactions in. And stuff like the drone solution that we'll be talking about later, we've incorporated that into learning as a real world story to see how creativity comes into play to address opportunities with technology, but not lead with technology to create an opportunity. So that one is an important one. And then last but not least is the community. I can't tell you how much I've learned from the community in terms of what people bring to the table. Everybody has a different experience. Everybody has comes from a different walk of life. I started my career as a car mechanic. I was my first jump into technology was when they introduced the ECU into the vehicles, and I was connecting via serial port on a 486 to an OBD2 connector and extracting data from these vehicles in terms of what's the problem with them and how to fix them. And this was amazing. And that's not even AI, not even machine learning at that time. It was just literally understanding, here's the problem sheet, and knowing by the error codes that was coming out from this car's computer what I needed to fix or what I needed to address. And that's where I moved into my career into technology. Bringing that to the table and addressing a problem first before even incorporating technology is what I brought with me from my experience as a mechanic. Other people bring other experiences. The one advantage I've had in terms of traveling around the world is listening to people in terms of how they address opportunities and experiences, everywhere from Europe to Africa to Australia, to you name it. And everybody addresses problems and opportunities differently. Community is so important to have that capability to listen. And amidst this pandemic, it's been even more beneficial in regards to the community coming together, because with us all being online, we're all connected. And yes, I miss the personal touch. I miss the handshakes and the high fives and talking to people face to face. But I've sat in a whole bunch of user group meetings from around the world that I wouldn't have had access to prior to this all going on. And you sit in a session in India and sit in a session in Australia, and even if they're not in English, there's a technology that's available that'll translate it for you. Just go out there, participate. Not just speak. Like I try to practice 20% speaking, 80% listening. Take in what you're learning, take in what you're seeing, take notes, also share, but do a lot of listening, do a lot of understanding, see what's going on around the world, and you'll be amazed how much you'll learn from other people.
Yeah, that's the exact reason why we run the Global AI October sessions. We want to connect people across the globe, because we feel that this is one of the ways that we can help people get new ideas actually for new projects. So it's really cool to hear about the ideas that you have, Fergus. And I want to thank you for your time today to show us actually what you built. And if anybody has any more questions for Fergus, please feel free to post them in the live chat. I guess Fergus can stick around in the live chat and have a look at that. And Alicia, I guess that we should definitely have a talk after the October sessions, and I have a bit of rest getting back from this, and we should definitely give this a shot and see what we can make. I'm excited, at least.
Yes, we have our boot camps coming up in February, and we'd love to have both of you involved, of course. And definitely, it's kind of heartening to hear that, you know, the genesis for some of these projects are building a better mousetrap. Like I think you literally said that, and I think we all feel that, you know, the mousetrap has already been invented, and there's not much we can do to make things better. But you know, there's always an opportunity to build something new. So thank you, Anthony, for that. And Fergus, it was great having you on.
Yeah, well, thanks so much for the invite and the opportunity to speak to you all. Hope you found it interesting.
Yeah, thanks.
Absolutely.
Hope to see you soon.
Yeah, definitely. Thanks very much.
So, moving on to Anthony, you've been on our show before, I remember, in April actually. I don't know if I was asleep during your session, or maybe I forgot because it was a 24-hour thing. I don't know about you, Alicia. Do you remember his?
I remember Anthony from our 24-hour run, 36-hour run, and I really enjoyed your blending of the technologies, and I love your spirit of community. So thank you for visiting us again.
Well, thank you for having me.
I'm really curious about the project that you're going to talk to us about. I know you've just shown the mousetrap thing behind you, and you've done a lot of stuff with drones. Can you explain to us a little bit what you've done with drones and how that works actually?
Yeah, actually, what I can do is I'm going to quickly share my screen. I don't want to go through a full-on PowerPoint presentation, but I did want to show a little bit around the technology of what incorporated what we built out for the solution. As mentioned, this was done in partnership with Indro Robotics. I'll just share this really quickly right here. So this was done in partnership with Indro Robotics. And like I mentioned before, the opportunity that existed was Indro had come to us and said, hey, we're doing this on behalf of the Canadian Coast Guard. They operate drones to, fly out to scenarios or situations where a ship is in distress, and it takes film of the scenario and then flies back. These drones are gas-powered drones that can, fly out to 3 hours out at sea, survey the area with aerial footage, and then fly back. And in flying back, it then comes back to the central office. The central office downloads the video from the tape, and then does the analysis of the the situation that's at hand. And that could mean that it's going through numerous hours worth of video to do so. And the challenge with that is, in terms of a life and it's in distress, every second counts. And there's also the preparedness of those services that go out to those scenarios to address the problem that's at hand. Is if you go out with a ship that doesn't have enough medical equipment to address the amount of people that are in the water, that's also another issue. And this piece here, as it was initially brought to us, was based on a technology ask. Can you help us provide a compression agent so that we can stream the video over a 14.4 kilobits connection back to our central office so we can be immediate in our response of a scenario? The biggest challenge with that is that, in terms of regulations for search and rescue, as you probably guessed, there's a plethora of rules behind the rescue of people from the drone perspective. And in regards to this, the video could not be lower than 720p in its quality. The video itself from the drone had to fly within a specific airspace. You can't just have it fly, anywhere. It has to fly within a specific band of airspace, and because of commercial airlines and what have you. And so, with all these factors that are put into play, there was, up to 5,000 hours put forth in terms of adhering to not only the regulations that are required, but also the specifications of the drone that we were given to do this proof of concept, to do the identification of the individual that's in the water. And that's shown by the examples that you see here. So this is a 720p camera at 5,000 feet. We had to test it at different type of weather patterns: sunny day, cloudy day, rainy day, snowy day, you name it. And to do that understanding of what it was looking at the water. Even the life jacket itself, is it red? Is it orange? What are we, the whole aspect of even how the hue of color looks in different aspects of light, or even in the dark, as how is the drone going to identify the life jacket when it's dark. There was numerous tests that had to occur in regards to this. The one thing I love telling people too is that I'm not a developer. I did not sit down and write a line of code, and I was grateful that I had this awesome team to work with and collaborate on in regards to this. I'm an infrastructure professional. I'm as what we call an IT pro that architects out the solution in terms of the where the data flows, who gains access to the data, what security aspects are put into play. But I also dabble a little bit in terms of architecture of these type of solutions, in terms of, can we actually make this happen? And what I meant, I mentioned earlier on, the technology that we showcased and we highlighted from this solution didn't even exist. Custom Vision .ai as a service wasn't even commercially available when we built this out. And a lot of people looked at me and said, you can't do that. There's no way. The technology, is not available for you to do that. We're still in testing. And, the engineering team said, okay, we'll grant you access to the service, but you have to keep us in lockstep. You have to, go through the whole scenario with us in regards to what you're trying to accomplish. And they were blown away because, it was 5,000 hours worth of training, but the building of the infrastructure, building of the technology, was done in the span of 5 days. And, the proof of concept has evolved into so many different types of solutions now. I've seen this scenario in terms of having the drone understand, structural integrity of buildings and understanding if welds were actually completed appropriately. I've seen the solution of monitoring the fields of crops to see if there's enough moisture available to specifically, let those crops grow optimally. And that's just from a drone perspective. Amidst the other toys that I have back here, I have a NVIDIA Jensen, which is a portable GPU. It's like a Raspberry Pi on steroids with a built-in GPU capability at a cost-effective piece that I can add a 720p camera to and bolt it onto anything, a vehicle, a light post, whatever that may be, for whatever operation I want to accomplish. Again, using the technology and the architecture that we built out on the drone. I include my URLs with the solutions that I was able to collaborate on with others to either share the story or to actually share the code and provide access to my GitHub repo for the code of what we've accomplished. And I love the fact that I'm able to work with the community and interact with the community on these ideas and these solutions and share what I've built in the hopes that other people share then with me what they've accomplished. And, we combine efforts and we combine learnings to build out something really cool and great. So as an example, we use this as a fictitious scenario, but it's something that's real world, and it's something where a lot of organizations are facing today. And amidst this pandemic, there is limited amount of people that are allowed in spaces because there's specific distancing that is required in regards to having even people staff retail locations or stores, not only those that are the customers that are coming in to participate. So this company, which is Tailwind Traders, has this exact problem. Every 6 months, they have to do a full count of inventory of all the products that they sell in a physical inventory count to have an understanding to see the correlation between what's listed in the computer, it's available for sale, and what's actually on hand. Now, this usually happens after hours. It has to happen in a time between, when the store closes till the next morning. But in a situation like what we're in right now with the pandemic, you can't have as many staff as you would usually have to do this count. So that becomes a problem. And so you look at, what's available out there in terms of technology that can actually address this. And so from that perspective, you have to look at a machine learning opportunity or to understand, how am I going to recognize all these objects and do these counts? Now, I want to call, in perfect point segue in regards to this, call out to one of my colleagues, Casey, because she heard, this story in terms of, what I've done with the recognition of objects for inventory counting, and said, wow, you're going out to Bing image search and you're pulling images one by one and creating this repository, and then putting it into the Custom Vision workbench for identification. How about if I automate that for you? And she wrote this great blog post on dev.to that highlights, the ability to extract information from Bing in terms of images, and then have that made as a repository for the learning of customvision.ai to identify objects. And I just want to call it her brilliant work. And again, this was based on a need in terms of addressing an opportunity that existed, that I was doing things manually, as opposed to leading with technology and saying this is going to be the next latest and greatest thing. Go and do this, right? So this blog post that she has is awesome because it takes you through the steps in terms of this enablement. And even somebody who's like me, who just dabbles in code, I would say I'm a hobbyist programmer at best, has gone through this scenario. It's been such a huge weight off my shoulders in terms of the acquisition of these images to teach machine learning how to identify objects through custom vision AI. So in terms of the demo itself, I'll show you what it looks like. So this is in essence the workbench that I would utilize or I would work with in regards to the identification of these tools or objects. The same workbench was actually used in a more rudimentary form because it was 4 years ago in terms of the identification of the life jacket as well. And so in this scenario here, I'm going to go forth. I've gone and used the solution that Casey has built in regards to the collection of the images. And I've gone forth and I grabbed the images, and this, for everybody at home and everybody in studio, what are we looking at right now?
Oh, a bunch of hammers.
We're looking at a bunch of hammers, right? And how do you know it's a hammer?
It's usually the shape of the head, and then there's a wooden handle or maybe a metal handle, but it's sort of the shape of the head, I guess, that gives it away.
Right. So you have a blunt object that's at the top, right, followed by a long handle. Yes, there are different shapes to the hammer, but that's in essence what we know as a hammer, right? And we're taught that as young children. To teach customvision.ai, you actually have to go forth and grab all these images, and then what we do is we actually label the images as what we know they are. So using Casey's solution to pull that imagery out of Bing, to create this repository that I would then upload into my customvision.ai workbench, label all these images as a hammer, and then I'm going to add another object. So what is the next object that we've just added?
A classic wrench.
So we've added a classic wrench to the mix now too, and we've labeled the wrenches so that again Custom Vision AI gets an understanding of this is a hammer, this is a wrench, and we're doing this on behalf of Tailwind traders to do that ability of understanding what I'm looking at so that it actually can go forth and do counts, right? So now we've taken these two objects, and we're only going to do two for now because we can do a plethora of objects made available to us in terms of customvision.ai.
And how many
However,
objects
of course,
can you...
limited by environment. Sorry.
So how many objects can you typically add to a dataset in Custom Vision AI before it breaks down?
It's dependent on how it's going to be used, right? So in this scenario here, what we've done in this specific project, we were able to do 72 objects. And I'll show you what the end result of this project actually is. But the limitation is based on your device and environment that you're going to be running this on. We wanted to emulate this as close as possible to what was available on the drone. In respect to the drone only had to understand one object, which was the life jacket. That was the trigger. And we had 5,000 hours worth of learning imagery for the drone in terms of different environments, cloudy day, rainy day, sunny day, what have you. But it was always just the life jacket, right? So the learnings for the solution in terms of customvision.ai was the whole aspect of learning to identify the one object in numerous environments. In this scenario here, it's on the flip side, we're going to learn numerous objects in a single environment. So you'd have to have proper light. So it was the flip side. So now we have 72 objects that we're trying to recognize in a bright, sunny, lit up environment, right? So it's totally dependent on how the solution is going to come to play in terms of your deployment of it. That's why understanding the solution first as opposed to leading with the technology is so important, because if you led with the technology and you come across this limitation, then you're stuck. But if you have a complete understanding of what you have available to you in your environment, then you have a better success of achieving what you're trying to achieve in your proof of concept and then quickly going to production.
So actually in this case, the tool is not so much advanced in its usage. but the scenario that you're going to use it in might make it very advanced. I mean, if we're
Correct.
talking about a flying drone in bad weather, lighting is not ideal. It might get lopsided pictures because it's blown away by the wind. Those kind of things.
Correct.
That makes this very advanced, actually.
That's correct. And so that's why I always suggest to understand your opportunity first before, as opposed to leading by technology. Because if you lead with technology, you forget about the nuances of a windy day and the drone having problems stabilizing.
Yeah, it makes sense. Yeah.
So let's continue on. So we've now identified, the hammer and the wrench, and we're going to train the model. We're going to do 2 objects here for the demo today. And I go through iterations of training. So this is now computer vision going through, doing an analysis of the objects that have been inputted and labeled as a hammer and a wrench, and to have the ability to then come back with this is of what you've fed to me in terms of data, the realization and understanding of what I'm looking at from a custom vision .ai capability. This means that with this solution of the 2 objects with 100% precision to understand what they're actually looking at, what the computer vision is actually looking at, and have a recall of 96%, which is very high. When you have more objects, you have to provide more objects to teach the solution to understand what it's looking at. So you do keep that into effect. I know with the drone solution, we were hovering around the 70% mark, which was enough in terms of regulatory that was required for search and rescue. But 96 is very high, and it's very uncommon, especially if you have multiples of objects that you have to put in. The more objects you need to recognize, the more learning or teaching that you have to provide to the custom vision model to understand what it's looking at. And do know that, if the model can't, if I have a hammer and a wrench and I introduce a screwdriver and I haven't taught the custom vision model what a screwdriver is, it's not going to be able to identify it. We're only teaching it what we're teaching it, and that's what it's going to know. It will try to do best guess to say, maybe it looks like a hammer, maybe it looks like a wrench, but its recall on that one object will be a lot lower.
And so when we talk about precision and recall in this case, what would you say is the most important metric to keep in mind when we talk about a search and rescue mission? Is it the recall thing, or is it?
Yeah, it would be recall. The reason why it's recall, because in precision, there is the possibility of false positives. In a recall scenario, you're actually, you're recalling your knowledge on a specific object. So that it's being certain about what it's looking at and its percentage. And I'll show you that in the example is very important, because you can actually set that threshold to say, if your recall is under 70% on the object that you're looking at, it may not be the object that you're looking for.
Yeah, so in this case, it's more important to actually find the person in the life jacket, even though it could be a false positive and it's actually not a person in the life jacket. We don't want to miss anybody in the case of search and rescue. Yeah,
Correct.
People often overlook this. People tend to, especially in the beginning, and I did the same when I started working on machine learning, I started looking at accuracy actually of this model. How accurate is it? But that's not always a good choice. In a search and rescue, it might be more important to find everybody in a life vest versus making sure that it is a life vest. In the case of the wrench and the hammer, I guess it's the other way around. We want to look at precision. I want to make sure that it's indeed a hammer in every case that I get a hammer in my camera view.
Correct, because you want to be precise in regards to understanding how many hammers you have in inventory, right? Yeah. That's why, again, it's so important to understand the opportunity as a whole in terms of what you're trying to address, as opposed to leading with technology, because there are different needs for different opportunities. And if you're following the technology first and not taking the needs into consideration, your proof of concept is not going to be successful.
Okay.
So let's continue on. So now we've gotten the data, we've gotten the recall data, we've got the precision data, and as mentioned, the precision data is important in this scenario, identifying the devices or the tools so that I can do the specific count. I'm actually going to export this learning. And as you can see through the custom vision.ai workbench, I have a plethora of choices that I can actually choose on how to export this learning. I wanted to do this as close as possible to what we did with the drones. And the drones being 3 hours out at sea, at 14.4 kilobits per second connectivity, it wasn't enough to do, a real-time connection for machine learning to have an understanding of what the drones were looking at. So in this scenario here, what we actually did was we exported the learnings through the tool as an Onyx file. Now, if you've dabbled in custom vision before, you know that Onyx is a great open source solution that's made available. It can be used in a plethora of different solutions and environments and what have you. It's the most malleable one that I've worked with thus far in regards to incorporating the solution into other functionality and other architecture. But as you can see, there's TensorFlow. You can run this in a container. There's even the Core ML offering that's available on iOS. So if you're again, you're enabling students that have iPhones, you have that availability to build out a solution for them to adopt and run with in terms of classroom, if that's the device of choice. The beauty of going with Onyx, however, is something where it works on everything and anything. And for me, the recall time on Onyx has been the quickest in terms of understanding what we're looking at with the solution as a whole. So in exporting it in as an Onyx 1.2 file, we bring up our Unity environment. So again, taking the same basis of the solution of what we've done with the drone, but instead of deploying it into a drone on platform that's made available for the drone to understand what it's looking at, we're going to take that same solution, that same model file type capability, and export it into a HoloLens. Now, a HoloLens, as you know, it's a Windows 10 device. It's got its own CPU, its own operating system, its own camera sense. The big thing with the HoloLens, as you know, is the availability to interact with 3D models on the fly. We call it augmented reality in terms of your environment. You can walk through and interact with 3D models as if they were actually in front of you. In this here, this is again the Gen 1 solution that we have available. And I've taken the availability of my GitHub repo through the community I've worked with. They have a code that's made available, and they allow it, and that's the beauty of open source. They allowed it for others to dabble with. So I've actually made available the original fork code that's available in terms of this solution, which everything here works in terms of the model file and made available. But the output, as you know, is going through a HoloLens for the object recognition. And I'll give you a quick example of what that looks like. And remember, we talked about the recall and the precision. As you can see here, we're going to look at two objects. We're going to look at a soccer ball and a basketball, and it's going to do identification of each. Pay attention to the recall, which is the percentages at the bottom there, because this device was taught 72, like I said, this proof of concept was 72 objects that it was going to go through and recognize. And in going through it, like I can recognize that this is a basketball at 69% accuracy, right? So the recall on this, it's a lot lower. So I would say, you know what, it didn't do a good job at that. This one, it knows it's a soccer ball at 100%, right? I wanted to showcase that difference between the two, because in the scenario of the life jacket, you want to be, in terms of your recall, hey, how many of these life jackets do we have? And then from the precision standpoint, do we say, okay, we're going to drop the precision to 60% because lives matter? We want to make sure that we can find everybody that is, in distress, and we can rescue them immediately. That was, the beauty of the capability of doing the threshold setting of precision and recall was of great importance, especially in the drone scenario. And of course, in a scenario where we're doing inventory, in regards to being able to identify objects to actually run a count on them. Now, oops, I went too fast. So I wanted to share this, and this is the computer vision tool set that's made available. If you're like me and you like to dabble in terms of hands-on and understanding the functionality and capability that's available out there, this is a great solution. This is a curation of resources that are made available specifically to computer vision that you can go forth and dabble with. Also, capture that GitHub repo link that I provided, and the drone link I have provided. It tells a story and showcases the architecture of how the solution was built, all of which, go out and replicate, but go out and start imagining. Go out and start understanding, hey, these are a whole bunch of opportunities that I can address knowing what this technology can do. Again, don't lead with the technology, lead with the problem, understanding of the problem or understanding of the opportunity first, and then see where the technology can be fit. And I challenge everyone that's here on this global AI community, go forth and teach me, go forth and show me what you're trying to accomplish. And I'm happy to provide resources to you in regards to upskilling or documentation or what have you in regards to trying to achieve what you're trying to achieve. But you gotta let us know first. You gotta provide us that feedback, so that we can understand how we can better, help you in terms of services, what needs to be modified, what needs to be created, what needs to be addressed, so that you can achieve what you're trying to achieve.
Thanks. I do have one last question, and then we'll move on. So we've talked about detecting live vests. Would it be especially hard to recognize somebody without a live vest? I'm asking this because I'm wondering how easy is it for a machine learning model like the one that's used by custom computer vision to recognize sort of difficult to see objects in a frame?
So the life jacket piece was an interesting one because we had the ability to identify a marker, and the marker was the life jacket. We also had to follow that up with an IR scan because identification of a life jacket wasn't enough, because we can count 4 life jackets in the water, but you may or may not have an individual even in that life jacket, which is another problem, right? So I've sent out the resources for 4 life jackets that flew off the deck because it was a windy day, and the ship is in distress, but it's because the engine has stopped, not because there were people in the water. The trigger was the life jacket. The added piece to that was an IR scan to detect the heat mass amidst that life jacket to understand if there was an actual body or an individual in that life jacket. And so, yes, you do have the capability to have an IR scan done, but without the life jacket as a trigger, that becomes then the challenge of the drone to survey the area to have a better understanding of what it's actually looking at, right? It can be done 100%, but is your restriction time? And how much more time would it take for these drones to identify, individuals in the water without life jackets? That's something that you would have to take in consideration for your project.
And from what I understand, is that instead of building one model to do everything, you actually build a model. You split the model in multiple parts. So first you take a trigger that decides this is interesting or not for my drone. And then you build a second model that's actually using infrared to make a decision, is this a human or not? So it's going from interesting object to a human in distress. And that's kind of cool, right, that you broke down this problem into smaller bits. From my experience, this is one of the key tricks that you have to apply to AI. Break down your problem in smaller pieces. That will help you. A computer can only do so much. That's what I gather from you showing off the computer vision, but also the stuff with the generating of objects in a 3D space. Yeah, that's kind of cool.
And add to that complexity what we had available to us in terms of hardware. So an ARM processor with 2 gig of RAM and what was it again? It was a 16 gig micro SD for storage. That's what we had to play with in terms of an environment to have the operating system run and have the application understand the life jacket, understand the IR, do the calculation on the fly in terms of time till hypothermia sets in, because it would capture environmentals as well, and then report back immediately should it be a critical time for those individuals that need to be rescued.
A very nice solution. I'm so happy to have you on the show. So thank you very much. There's a ton more questions that I have, and I'm sure that people in the stream, in the live chat, also have more questions for you. So feel free to stick around, and we'll move on to our next guest, Noelle Silver.
Hey there.
Hey, hello.
Hey, Noelle.
I wasn't sure. I'm like, do I just jump on in? But Anthony was awesome, so that was phenomenal. I was like, this is so cool. So anyway, thank you.
You're welcome. Welcome to the show.
Go ahead.
Oh, I think he was just saying welcome. So thank you for having me. I'm super excited to be here.
Cool.
Yeah, we're delighted to welcome Noelle Silver. Noelle Silver has a long history and a long list of contributions to the AI community, and many accolades with Alexa skills, and I know you have a heavy background in voice, but I'm most excited about your contributions to women in technology. I love working in the data and AI space because there is just so many women in this space, and I think that there's so many women because of women like you who make it a welcoming space. So thank you, Noelle.
Thank you. That's awesome. Well, yeah, I hope there's more of us. I always say, like, come on. Especially now, Anthony did a great job of explaining, like, you don't have to be any special person. Like, you just have to know a problem or be empathetic to a problem to be able to solve it with these technologies. And so I'm just like, open the gates, let them in.
Yeah, so we've seen that ethics has been a big consideration when designing these AI systems, and we're looking forward to your session on explainable AI.
Absolutely. Do I just like go into it and show it, or what should I do?
Absolutely. I don't know what you brought. Did you bring a set of slides first?
Can I share my screen?
Yeah, go ahead.
All right, I'm gonna do it. Let's see. Let's hope it works out. There'll be a little. Oh no, there we go. I think you can see it. Can you see it?
Yes, absolutely.
That's me. Okay, and my people. So I'll just get started. I'm here to talk we don't have a whole lot of time. And so I want to talk about responsible AI in general, but very specifically about what data scientists and modelers can do to build more explainable models. But before that, I always like to give a very brief, 2 minutes of who I am and why I even got into this space. So thank you, Alicia, for telling everyone about like my start, which was in Alexa. I was an early member of the Alexa team, and part of being part of that organization, we didn't know what we were, getting ourselves into. The product hadn't been proven yet. It was still in beta. We had less than 1,000 users. Like, it was a baby product. And as I was on the data science team for a couple of years, and we were just trying to like keep up. And we weren't really having a lot of luxury of being able to sit back, take time, and think about how we were going to do everything, every little thing. But so now I'm pretty passionate about sharing with people, here's what you could do if you find yourself in a situation like this. And that's what I'll focus on over the next 20 minutes or so. But before that, the reason I even got to Alexa was because I had 2 people in my life that needed solutions, very similar to what Anthony was talking about. Like, there was a problem that needed to be solved. My son, Max, he's there with the heart. He has Down syndrome, and he was really struggling as he's now 15 years old, as he starts to get into kind of high school education curriculum. And he's brilliant. He's very smart. He can do a lot of work, but he's limited by the vehicle upon which he can communicate to the technology. And so Alexa being born a few years ago really created the opportunity for him to do more. I also have my dad, who's an aging, he's like in his 70s, but he suffered a traumatic brain injury. So he's got a lot of cognitive challenges. Also, not a great candidate for like the super smartphone or the keyboard or the mouse. So I wanted a different world for them. And that's really what drove me to where I am today, which is not only advocating for use cases like this, but also for technology in general and for diversity of thought around all the things. So last year, and I guess over the last few years, I've gotten lots of accolades. My favorite, the reason I love this slide is because I got a 3D printed Ninja Cat, my prized award possession. But I got a lot of awards for just being willing to say out loud, we should think differently about the way we're doing things. A lot of times as an engineer, you just go in and heads down, you solve a problem, and you often might solve it from your own personal perspective, but very rarely do I have the luxury as a data scientist to go talk to the person who originated the problem or who has the pain. And that's a lot of what we're going to talk about now, is how do we really create empathy in our engineering teams, and what are the tools available to deploy that. I always like to start with this quote, and the reason why is because it's actually a data lesson. So I'll quickly read it to you. I know I'm never supposed to do this, but those of you who've seen me before, this is my favorite thing. But what is success? To laugh often and much, to win the respect of intelligent people and the affection of children, to earn the appreciation of honest critics and endure the betrayal of false friends. To appreciate the beauty, to find the best in others, to leave the world a bit better, whether by a healthy child or a garden patch or a redeemed social condition. To know even one life has breathed easier because you have lived, this is to have succeeded. Now, during my time at Amazon, Jeff Bezos actually was the one who shared this with me, but I've actually had this quote shared across my technical career. And one thing that was true about all of those who shared it with me was they said it was written by Ralph Waldo Emerson. That's who wrote it. And after a few sessions of delivering this in global audiences, someone was like, go look that up. And I did some research and found it actually wasn't it wasn't Ralph Waldo Emerson who wrote it, who is, he definitely made it popular, but it was actually Bessie Anderson Stanley. And oftentimes there's a lot of things in our work that are presented in a certain way, but upon further kind of digging, we find that it's not always the truth. And I feel like as a data scientist, as a data, like an AI engineer, someone who's applying the models that are becoming democratized, I want to dig a little further. I want to know what I'm using and why I'm using it and how I'm using it. And so a lot of what we're going to talk about today is about what tools you actually have. Now, I always say this, we have more power than ever. It's a great time to be alive in tech. And I always ask this question. With great power, right? AI gives us immense power. But with great power comes, and if you're in the live chat, you can jot it in there, right? How do you finish that quote? Do you know? Uncle Ben, Spider-Man. With great power comes great responsibility. And that's really what this talk is all about, is that hopefully you're going to walk out of here as a modeler, as somebody who does this work every day, and never be able to do that work the same way again. At least that's my hope. Or at least a spark of thought, a new idea will pop into your head when you start doing this work. So ethics and responsible use of AI is a big, huge topic. As a matter of fact, fairness in AI is also a gigantic topic. I only had a little bit of time, so I'm choosing some very practical things that you can do today to build explainability into your models. But there are lots of research. Hundreds of research papers that you could read on different things you can do to build a better model. And that's really the question we're answering, right? Is how do I build a better model? How do I build a model that doesn't disenfranchise or doesn't marginalize? And it's hard work. And a lot of times our teams are not built in a way that would even recognize it if we were doing that. So one of the things I like to always mention here with you is look around your team. Make sure that either you have a team that represents a diversity of thought, and I don't just mean gender and ethnicity, though I do mean that, but I also mean introverts, extroverts, people with special needs, people who are hard of hearing. Everyone is necessary when we are building these models, because at the end of the line, in other words, when we push a model into production, the reality is that everyone's going to be using it. And the only way to truly serve those people we're building for is to make sure they're empathetically or physically involved in the development of the models as we build it. So this is all based on this concept of the principles of AI. In case you don't know, I remember a couple years ago, I think it was at Ignite or one of our conferences, the AI teams handed out this really cool ruler. And it was a black ruler, and it had in gold writing the golden rule, and it had all of these principles on it. And I loved it. I thought it was such a good pun, if you will. Like, what are the rules? This is what you should do. And I just want to remind you of them. We're not going to go through them. I just think this is really the undercurrent of why these tools are becoming more and more prevalent in our organizations and in our conversations. So explainable, I know the title of this was like explainable versus interpretable, but of course, if you know me, I am a both and kind of person. So I believe that explainability and interpretability are hand in hand, that they're really two ways of describing our interest in making our models understandable, in understanding the decisions that they're making, and in my mind, to specifically eliminate bias that shows up when we don't ask those questions. So, but we don't even have to worry about bias, because if we do the right things on the front end, ask the right questions and use the right tools, which I'm about to show you, we don't have to worry about bias explicitly, because by asking those questions, we will uncover bias within our models. Now, I do think we have to take care, and we have to do this intentionally, but I just mean that these tools will help us do that even if we're in an organization that does not value those questions being asked. So I do want to just mention to you, there's this really great tutorial I encourage you all to go and take a look at. It's called, I think it's like AI, Explainable AI. Just Google it or Bing it, and it'll come up. I also put the reference to it at the end of the deck, which we'll share with you. But there's 3 different waves, and this is so true of my journey in AI. I started off really building logic-based natural language applications where I was really creating rules, decision trees, very simplistic. I used to call it weak AI because I was like, this isn't really AI if I'm hard coding every decision that'll ever be made. But there was it was symbolic AI, now that I know a little bit more about that. And that was 7 years ago. And then some organizations transitioned away from that towards more of statistical models, right? And identifying these domains for training and using big data to train the model. And that's kind of where we are today, right? We are, for example, on a product like Alexa or Google Home or any of our natural languages, or even the work that Anthony just talked about in training custom vision. You're feeding it massive, potentially massive amounts of images in order to train the model to do what we want. And then using statistics, probability to determine confidence. So we're there. What we want to do now is take it to the next level, right? Gauntlet thrown, challenge accepted. We want to take our statistical models and apply constructs for explanation. And when I'm talking to people, I used to wear a shirt, I'm not wearing it today, that says I heart AI. And when I would go through the airport, people would be like, that's going to kill us, right? That's Skynet, right? And I'm like, well, no, not if we do things a little bit differently. And I feel like explainable AI is one of the methodologies that you can implement to protect yourself against these black boxes that we might be creating in some of our models. So really quickly, I kind of already said this a little bit, but just to reiterate, our current systems are machine learning centric. They are statistical and probability based, right? They give us confidence numbers. And oftentimes, well, I actually always I'll ask this question in just a moment, but oftentimes in finance, in marketing, security, in the business will be like, great, that's awesome. How do we do that? How do we make that decision? Why wasn't it this decision? Why didn't we choose something else? And if we can't easily explain why our model made that decision, it actually creates distrust between the people we're trying to help, right? The modelers, I am trying to build a solution that's going to help a business, help a newsroom, help, curators at an art gallery, right? I'm trying to help them solve a problem that they have. And if I don't do it in a way that's explainable, it creates distrust because they don't understand why or how that decision is being made. So it makes it really important, not only for us, because we want to be able to eliminate bias, which is a nice reason, an incredibly important reason, but also because we're serving a community with this technology. We're building models that serve people. And if we want to serve people, getting them to believe, invest, and understand what we're doing is part of that puzzle. And so explainability helps in that way as well. So why do we even need this? Just to reiterate, right? Really, it comes down to one thing. Bad decisions in AI models are dangerous. So I always like to ask you all that are listening, can you think of an example of an AI model gone bad, gone wild, gone rogue, that has made a bad decision? Go ahead and jot it in the chat. There's lots of examples because we didn't ask these questions. Even 5 years ago, models that went into, models that were deployed or went into production, especially in the startup world, we had challenges. We're now even seeing companies like Amazon and IBM pull out of facial recognition because they're like, this is not good. These models are making bad choices. So bad decisions can be dangerous, especially in the areas of, right? Hopefully someone thought about autonomous vehicles. That's not good, right? Or finance, credit decisions. Or I don't know if you've heard about the one where somebody created one around judgments, like in the actual judicial system or in the prison system. When you have bad decisions in your model, it doesn't mean your model's bad. It just means it doesn't have enough data. It doesn't have a diverse enough set of data. It doesn't have enough information to make the right decision. And so having explainability, though, allows us to tease out those bad decisions, figure out why the model made that decision, and train it to make a better one. And that really is, that's why I always say, never give up on a model. Okay, that's not true. In AI, I try to avoid absolutes like always and never. But be very hesitant to give up on a model like we're starting to see some companies decide to do when the solution might actually be just spend a little time, be intentional about your approach, and take the time to debug your models. So that's really kind of what we're talking about here, are different mechanisms you can use as a modeler to debug your solutions. So here's an image, and this is really what scopes our conversation today, because I think a lot, and I'm asked a lot by executives about, like, how are we going to do this? And oftentimes, and a lot of people are like, do you let an AI model make 100% of the decision? Now, those of us in this industry know that that's usually not the case. We have today on the left-hand side, right, this, or maybe it's the right hand for you, I don't know, standard ML, right, where we've got data, we ingest data into a model, we allow that model to make predictions, and then there's some errors that occur. What we want to do is have that same process happen, but instead inject interpretability, the ability to see into how those decisions are being made, and then let a human like me look at that data. And this is similar to what is done in custom vision, for example. I go in and I look and I go, why do you think that that's a wrench when it's actually, needle nose pliers? Why do you think that? Let me go in and figure it out. It requires human inspection. But the nice thing about that is that when you use human inspection, you gain additional insight that can be documented along with your model, increasing its explainability. So as it says here at the top, I believe that this is a both and solution. So let's talk through a couple different examples. I call these human approaches to explainability because there are packages that are available, I'll mention them at the end, that you can use to actually basically go through your models and extract out things that are potential concerns. I like the crawl, walk, run philosophy. It's how I learn to code, where I do everything by myself first. I write the model from scratch first. Then I use an applied AI model. In this case, I like the idea that we learn how our models work manually. Like, we go in and we look, we do what I'm about to show you, walk through these three approaches. And then we go ahead and automate those processes with packages and tool sets. But I do think there's value in really understanding how this works yourself before using a tool to automate it. So the first approach, and I'll go through these rather quickly, we are going to have a panel, and I believe right after me, you're going to have a really nice deep dive on PyTorch and how to build explainability there. So it's going to be a really exciting talk, so I hope you'll join us. But in the first, I have three approaches I want to quickly go over that I feel like I can cover in my short amount of time in enough detail that you can start using it immediately. One is post hoc, after development, being able to just explain your model. So this is literally like whiteboarding it out, being able to present it to a business stakeholder. Oftentimes when I present a stage of development for an AI model, I'm asked enough questions in that it forces me to go back and create explainability in my model. This one, in my mind, is kind of, I don't know, somewhat the easier way to go, because it is you looking and understanding a model that hopefully you created and then defining and creating explanations for that. So hopefully this is self-explanatory. Let's get into some more complicated versions. Ablations are another one. It's actually taken from the surgical world. Well, maybe it's not even original to them, but this is where you drop a feature, right, and an attribute, and you change the prediction of it in order to actually see how the model reacts. Now, before we get into this, I actually want to see if I can, I'm going to escape out of my presentation and just show you a way of testing out this concept of feature identification. And I'm just going to do it right in the browser because I know we have, oh dear, am I in the right place? Let me go back. So I just want to test it out right in the browser so you can see what it looks like. It's really kind of neat that you could do this in my mind. And it's to make a point. I mean, I don't expect you all to go here. I would hope that you just build it out in your development environment. But if I go into computer vision, right here, it allows me to submit a image into, you'll see down here, right, into a model and get metadata back. So the nice thing about doing this, and I'm just going to upload an image. I don't know if you all saw it, but about 2 years ago, I did a computer vision, a custom vision example on a very famous character set known as, I have to be very careful here, Chip and Dale Chipmunks from Disney. And when I choose that, you'll notice the metadata that the model gives me back is like teddy bear, cute, nice, a toy. So this isn't right, in case you don't know. And so what I want to do is, what we want to do as we are building explainability into our models is go through these examples, identify where the errors are within these decisions, and find out why that error exists, right? Like, it's 74% confident that this is a toy. That's relatively high. So I want to be able to explain why that happened. And then most importantly, how do I train it on a way, like, how do I train this model so it makes a different decision? With custom vision, it's kind of nice because I could do all of that without code, but it doesn't really matter. It all comes down to labeling. I want to be able to go in and create new labels that identify what I actually want the model to understand, as opposed to it defaulting to some level of truth that it got from 1,000 other images that looked kind of similar. Now, in the second slide that I just showed you, I also talked about gradients and gradients against a baseline. So when you're building explainability into your model, baselines are really important, especially as you talk about attributions. And so you want to establish a baseline of, like, this is Chip and Dale, these are chipmunks, they are Disney characters, they are in costume. You want to establish a baseline of images that is the ground truth of your model. And that way, as you go through these tests and you get failure results, it's easy to map it to some sort of ground truth. But in addition to that, you can train your model on gradients, right? On feature gradients. So you take a feature and you provide, especially in custom vision, it's kind of easy to think about. If you're thinking about the gradients of this image, I might have one that is super dark, one that's super light, one that has high contrast, low contrast, right? Different gradients of clarity on the image, and train it on the exact same labels so that I can get the nuanced decision making to be more accurate as the model starts to evaluate these images. So it's just kind of, I like being able to just go in here, throw up an image and see what this ResNet trained model would give me. But you could do the same thing with your own model. This is easier to do in a lecture type environment, but something that you can do for yourself as well. So I think I just, I'll just go back into presentation mode really quick. So being able to go in and then look at the features that I'm identifying and drop one and see how my predictions change will also help uncover this. The only challenge with this is that, at least that I've experienced, is the level of compute it's pretty expensive. In other words, you have to process lots and lots and lots of these images. So I also like this idea, and I would be remiss if I didn't mention the studies that support these human intervention ideas around modeling feature absence, or modeling or building explainability into your model. But in this specific example, we're talking about, like, look at the prediction that's going to be made, and now instead of just like what I would have done in a computer vision or custom vision scenario and just extracted a feature and seen what happens to the prediction, I can actually take a sample of data and do that, a very similar exercise, but against a sample. And that will give me a slightly different result, but it will allow me to, as a human, as the modeler, to discern why those decisions are the way they are. And so in this, scope of a few minutes that I have, I think these three things, if you can do nothing, just start by being able to explain the decisions your models are making, right? Just start there. Set the intention when you build a model that you're going to ask the question, why does this happen? And then have an answer. You could have that answer because you just know, But in deep learning or in neural networks, it gets exponentially more complex to create that explainability off the top of your head. So that's where tools come in, tools and resources come in. And we want to really, again, do a combination of both. Make sure you're asking the right questions, driving towards those answers as you're building your models, but then also leverage some tools. So I put up here some resources that the team at Global AI shared with me that I thought were amazing and I had not read prior to joining, but also some tools that I had personally used and a tutorial, a couple of them, for you guys to have a chance to go and build this yourself, right? We only had, 30, 25, 30 minutes to talk here, but the next step is doing it. Like, get your fingers on a keyboard, build a, you can use one of the models that are provided. You can see down here, leveraging Fair Learn. But there's a lot to be said about the human discernment and the intention that we set as builders, as modelers within these projects. If you don't have, I hope that you have the support within your organization to be able to call a model bad when it's bad, be able to pull the chain and say, this has to stop, we're doing the wrong thing. But if you don't, encourage your organizations to join, organizations like Partnerships on AI or Mira or Rates, or there's all these different organizations out there that will help companies align with ethical and responsible AI solutions and strategies that serve their bottom line, that actually align with their business values as well. So I think that's probably all I have time for. I did want to give you a chance to connect with me if you want to learn more. I do have a bunch of different tutorials and videos and resources that I always send to people. So if you connect with me on LinkedIn, I'll just copy and paste my resources right in there. There's also a set in this deck that you'll get at the end, but it's just the beginning. So thank you so much for having me. It has been amazing to be part of this full day, and just think ethics, right? We're here, we have a lot of power. Let's be responsible with it. Thank you.
Great
Thank
presentation.
you, Noelle.
And the crowd goes wild.
Oh man.
So we do have some time with you in our panel discussion. But first, up next, we have Seth Flores joining us.
Okay, bye, Seth.
Doodle.
We'll see you in a bit, Noelle.
Oh, glad to have you back,
How's it
Seth.
going? Can y'all hear me?
Yeah, loud and clear.
It's working.
Yes,
How's everybody doing today?
pretty good. We're having fun.
Woo! Jazz hands.
Fun fact. Alicia and I went to school together.
Really?
Yes.
Graduated the same year from the same college.
Ooh.
And here she is out shining us all.
That was, what, 5 years ago, Seth, right?
Yeah, that's right. Look. 5 years ago. That's right.
That's been a long
So how's
time.
everybody doing? We having a good time?
Yeah, we're having an excellent time. We discussed drones, self-flying drones even, that are capable of detecting people in the water. So there should be some deep learning in there, by the way. And we've had a talk about explainability and how that's important.
I've been watching. It's like this is the good programming for today, and so it's all good stuff.
Yeah, we're getting into the advanced stuff. And
Yeah. So the thing that I'm interested in and that we're going to be talking about now is what is actually going on in a deep learning model and how it actually looks at stuff. So we're going to get into the actual nitty-gritty of all of it. And if my hair gets all crazy, it's because when I talk about maths, I mess up my hair because then everyone thinks it's smarter that way.
I pulled out all my hair by now. I mean, I've got almost nothing left because
Yeah.
of all the maths involved in deep learning and machine learning in general. So I'm curious. Can you show us?
I am going to share my screen if that's okay.
It's absolutely
So
okay.
basically what we're going to do is I am going to show you here. Let me minimize this thing. And by the way, if you have any questions, please ask them because I'm super interested. And I'm going to go like really, really fast through a bunch of concepts and some maths. So basically what we're doing right now is I'm going to show you how to build You saw the cognitive service early on from Anthony, right? And then you saw Noel expertly take a look at how to make them explainable. I am actually going to explain what is happening inside of these models, okay? And so what we're building effectively is this. We are building an AI or a machine learning model that looks at pictures and tells you whether it's a taco or a burrito. This is more of an enchilada, but still. If it's a burrito, I don't know how that one got in there, but if it's a burrito or a taco, because this is what we should be looking at when it comes to AI. We need to be looking at whether foods are good or bad, right? And burritos versus tacos is the quintessential machine learning project. And what I'm going to show you is basically I built a machine learning model that actually looks at pictures of these things and tells you whether they're burritos or tacos, right? So I already ran it. Sometimes my GPU doesn't like it if I'm doing too many things with the GPU. And so if it doesn't work, I've already ran these things. There you go. So basically you can see here that this picture, it says it's a burrito, right? It even tells you the scores. And this picture says it's a taco, taco, by the way. And you can see the score as well. And if you want, I can go to this particular picture here. And let's go to browser, the browser here. And let me bring it over. Let me put the picture in there so you can see it. Oh my gosh, I gave it a pizza and it thought it was a burrito. There's the joke. Joke's on me. But you can see that as soon as we get into the ethics of this, you're realizing that when it looks at a pizza, it thinks it's a burrito. And you're probably wondering why. And I'm going to show you why. And I'm going to show you to a degree where you're going to be, you might not understand the whole infrastructure, but you're going to understand fundamentally what it is that this thing is doing. And then by extension, you're going to immediately understand why we need to understand how it works in order to make ethical choices. So basically, when we're talking about machine learning models, model is, for me, is a lazy way of writing a function with data. Just think, if you're a programmer and you think of the word model, just think function. And a function is this function thing. But the model, we have to tell it what the shape of the function looks like, and then there's internal parameters that it learns. In our case, with deep learning, it's just numbers, right? So you got to first think about this model. It's a function, right? Then you need to think about this notion of a cost or a loss function. This tells us how bad we are at it. So again, I'm going to be super fancy and use the pen here. This thing right here is the model that we learned. This here is the actual right answer, and this function tells us how sucky we are at it. So for example, if the loss is 0, that means that the difference between these two things, right, if you were to subtract them, is 0, which means it's exactly right. Whenever these things are not right, you get an answer that's non-zero from this cost function, and the optimizer's job is to minimize the loss that we get from our model and our actual target, which is the actual answer. So in this case, we're going to have a bunch of pictures. That's the X. And then we're going to have a bunch of labels that says, that's a taco, that's a burrito, that's a taco, that's a burrito. But it's important to recognize how we set up the problem so that when we give it this thing, the pizza, we know why it's saying it's a burrito with such high confidence versus a taco, okay? All right, so by the way, get your questions in and just interrupt me as we go. I don't have a lot of time, and I'm trying to cover like a couple of semesters of a grad school class. So let's talk about creating a model. So how do we make this H thing, right? And we're gonna build a really tiny dumb one, and then we're gonna construct it all up into exactly what it is that we're doing with the burritos and tacos. And if you're wondering, we're using Inception v2 on that one with transfer learning. So first, what does the X look like? And what I'm going to do is I'm going to shrink the problem down to something really dumb. We're going to make a machine learning model to look at a 9-pixel picture, a grayscale picture, and we're going to guess whether it's darker at the top or darker at the bottom. So we got to build a construct. So I'm just going to build one. We're going to build this thing right here. Remember, there's 9 pixels, X1 through X9. Those values range between 0 and 255 because it's a grayscale image. And your job is to invent W's such that when you multiply all those pixels together, you get an answer whether it's darker at the top or darker at the bottom. Let me go back because I went really fast. Here's the picture. If you look right here, here are the numbers. Notice that those are the top 3 numbers here, right? And then these are the bottom 3 numbers here, right? Right here. So these are these pictures. So for this one, it's clearly darker at the bottom. So you can see that if these numbers here together versus these numbers here together, that will tell you what you've got to do. But I forced you to construct it this way, okay? So let me show you how it works. So here is a picture that's clearly darker at the top. Whenever I put these numbers in, I guess these numbers, notice that the answer is going to be positive, which tells us it's darker at the top, okay? Let's go to the one at the bottom. I'm going to add these numbers. So I'm handcrafting these fake W's such that when I pass these numbers in, notice that when I do this, we get a negative answer. So what is actually happening? These numbers are multiplied by these numbers, like so, right? And then once those numbers are multiplying them, we're adding them all together. And then out comes an answer, which is this thing right here. Notice that pretty easily you're able to create W's yourself such that you can guesstimate or classify this rudimentary picture into darkness at the bottom versus darkness at the top. If it's negative, darkness at the bottom, positive, darkness at the top. Now, here is a goofy question that you're all happening because there's this bee. Where's my mouse? Oh, I'm old enough to where I can't. Oh, there it is. So there's this bee just hanging out here, and you're probably wondering, what is this bee? Well, here's the thing. What if the problem is such that we want the top to be, let's just say we want to guess that the top is, if it's a little bit, like if it's a certain percentage of darkness from the bottom versus the top, we still want to guess top, even though it's not darker. We can add a positive number here such that it biases it towards answering top. We can add a negative number here such that it biases it to answer bottom. In machine learning, this particular term is called, get ready, the bias, right? So here what we've done is we've basically constructed a machine learning model, right? This W that we just formulated, given this pixel, is that h of x, right? We've basically constructed one such that we have to figure out what these parameters are. And if the number is positive, we guess top. If the number is negative, we guess bottom. So this W and this B becomes the actual model construct, and this becomes the prediction. Crazy, right? You would never use machine learning for this, but I want you to see what's going on. You might be thinking, well, Seth, what if we want to guess top, middle, or bottom? Well, you just make 3 of them, and now you're getting into things like linear algebra, right? Where you take this this thing right here, and you vector on the side, and you turn it on its side, and you go num, num, num. And notice that what this is doing, if we have 3 of them at the same time, is this is adding the first 3 terms, putting it in this one, adding the second 3, putting them in here, and then so on and so forth. And we just guess the one that's darkest. Right? We might even divide by the sum of this stuff, and then this comes out looking like a percentage of some kind, like 87% versus 62% versus whatever. These need to add to 1, so this is completely wrong. But you get what I'm saying. These are just sort of densities of the answer that are coming out. That's why I'm very reluctant, friends, when you see percentages coming out of neural networks and you're saying, oh, that's the percent confidence. I guess it can be that, but it's not actual statistics. So just be aware of that. Okay, so again, top, middle, bottom. Now, instead of a single vector of W's and a single scalar of for the bias, we have a matrix W for the weights, and then we have a vector B for the biases. This is what this looks like. Right? If you were to put this in neural network drawing, right, all these lines, the numbers that we're multiplying these things by, the number 1, 1, 1, and then 0, 0, 0, 0, 0, right? And then out comes this number, and then this is the density that we saw before. For us, there was 3 numbers, right? For larger problems like tacos or burritos, the answer is going to be of size 2, right? But this really doesn't work for bigger models. So what if we make it bigger, right? What if we do this? Then all of a sudden you're thinking, well, now we're making a neural network, right? And you're like, oh, wow, this is starting to get into coolness territory. Well, it turns out that if you were to just stack them and then do these matrix multiplications, the problem with linear models is that they force what's called a linear separation of the space that you're trying to guess. So in your mind's eye, think of points in 3D space, right? The W, what it does is it makes a plane in 3D space and separates the points for you. But what if the points are not able to be separated by a line? What if you needed to have some complex separation? Because effectively what you're doing is you're trying to come up with a function that separates the classes of things that you're trying to guess, right? So it turns out that just stacking them doesn't do anything, because a linear combination, which is what this is, of a linear combination, which is what this is still a linear combination, and you can prove that simply by using mathematical induction, which is really cool, right? I'm not going to get into it because I have like 15 minutes to finish semester 2 of neural networks, right, in a grad school course. So it turns out that you can keep stacking them like this, but it won't make a lick of difference unless you introduce what's called a nonlinearity. And the way to do that is to add what's called an activation function in between. So you're multiplying this matrix times that thing, right? Then you're running a function across all of the things in there, introduces and then you do it again and you do it again, and then all of a sudden you start to have things like this, which are neural networks, right? This neural network looks like it takes a picture of a number, and then it multiplies it, right? And then it runs the function over it, and then it multiplies it again. And notice that as the network goes, the space like shrinks down, right? So notice that at the end, since this is the digits problem, it's only going to have a density of 10 because, right, there's 10 spaces, and if it's the highest number is in here, then we get 0. If the highest number is in here, then we get 9, right? And that's how this goes. But it turns out that with images, right, if you were to take an image and then strip out the color and then line up everything in a single row, you're going to miss things like, for example, pixels on top of each other. And so there's these interesting neural networks called convolutional neural networks, which do like a dot product over images, right? Let me show you what that looks like. So here is here's Visual Studio Code, and what I've done already for you is I've made a convolution. So let's go here, and let me do this filter right here. By the way, doesn't this look familiar? 111,000 -1. Remember, that was the same thing we invented before, but here's a filter or a convolution over an important picture. Obviously, the wedding picture, super important. Notice what a convolution does to this picture. Pow! Notice that this convolution actually creates edges. And then there's this other thing called pooling, which makes it enhance it, right? So with these numbers, I was able to go over the picture and create edges around it. Let's try one of the kids, because obviously the kids are super important. Here's the kids, right? Notice that we are going to do an image. Notice there are the edges and there are the enhancement. Now, what if the computer could come up with its own convolutions to do crazy things? Like, for example, here's a serious image. So here's the fence. Notice that with the fence, it's able to find exactly where the things are going on, and I just chose these numbers, right, myself, just like we chose the numbers before. So the question is, well, how do we get all of these W's and B's without us having to choose them indiscriminately, because these images can be super large. Now I'm using the computer vision example, but this also works with all the other things, because eventually you have to convert these all to vectors and matrices. Well, we want to minimize the mistakes, and so we create this loss function. This is called the mean squared error, and it looks complicated, but it's not. Mean squared error basically means if I were to take the answer, right, let's just say we guessed the number 3, and the real answer is actually 3. Notice that this here equals 0. But anytime we guess something that's not right, we get something that's not 0, and then we square it. And this loss function basically says, how bad are we at predicting the right thing, right? So it's called the sucky function in non-specific terms. Okay, notice that again, this is the model that we have, W transpose X plus B minus Y. And now what we can do is we can use some special maths to figure out what exactly the appropriate W's and B's are, and we have to resort to calculus. Now, here's the thing. This little doohickey here has a square here, so we're going to pretend that it's something like this. And notice that in school, you remember this particular function called a parabola. Now, imagine you're like a blind Mario. You can't see, right? Mario lives in 2D space, and you want to know where to walk to get the optimal value, which is 0, right? Because we want this all to equal to 0. We want to set it up in such a way so that this equals 0. Well, how do you do that? Well, Mario needs to walk down this way until he gets to here, right? So how does he know? Well, why don't we do this? Why don't we do this? Why don't we just tell him? Like if you're Mario, what you would do is you'd put your foot a little bit forward and a little bit backwards, and then what you would do is you would measure like which place is higher, right? So we're taking a little bit of the x, let's just say dx, and we're taking a little bit of the y, dy. And what we're going to do is we're going to divide them, dy by dx, right? And then what we're going to do is we're going to take the limit as this distance h goes to 0, and this effectively becomes what's called the derivative. And the derivative tells you the slope which we should go into to do that. So how do we do that, right? Well, it turns out that PyTorch tensors are actually super special. Let me show you why. Let me go back to this thing right here. So PyTorch tensors are actually really interesting because when you are creating, so here's the tensors, right? Notice here's our W and here's our B. We're taking X matrix, multiplying it by W, adding the B. Here is the loss function. Notice what PyTorch does is with any function, it actually keeps track of the variables that you want to retain the derivatives for. Derivatives in multiple directions are called gradients. And so that's what it does. And it turns out that in its internal state, it actually remembers what the derivatives are, and it knows how to iteratively, as you go in a loop, it calculates the gradients, and then it knows how to walk in the right direction. And for walking in the right direction, basically what it does, if you take the gradients and you subtract them off the W, and then you keep doing that until you reach some optimal state. And notice that all you need to do to figure out the gradients is do loss dot backward, and all you need to do is subtract this from the current W's and B's, and you keep doing this until their loss goes to as close to 0 as you can. When you're setting these up in PyTorch, you can actually create really cool models like here's a linear model, right? Here is a neural network model, right? It keeps all of this, and because add and matrix multiply happens so much, there's basically a single op to do that, which is really cool. And here is this convolutional neural network, right? You can see it starts to get deeper and deeper until you get to the actual model that we're going to use, which is called MobileNet, right? Notice how deep this one is. And this is the actual model that we learned to do tacos versus burritos, okay? So if I were to go in here, let's go to some numbers. This is a model that's already trained. Notice you have this GMM. It stands for generic matrix multiplication plus the addition of the bias. Here you have the actual matrix, right? 2 by 1,000. And it turns out, remember how I told you that the neural networks get narrower as you go down? Notice that the output vector is going to be of size 2 because we're only guessing between tacos and burritos by math. This is how we're doing it. And notice that there's 1,000 inputs coming, and then it's going to be whittled down to 2, and then we have this softmax function. The softmax function forces it to sum to 1, so it looks like a percentage. Okay, so that's what's going on there. And now when we go back to it, if you're looking at how it predicts the pizza, notice that the majority of the weight landed in burrito because that's all it could predict. It had no other notion of anything else because when I train the model, which I do right here, notice that I only give it burritos and tacos. Right? Right here. Burritos and tacos. Those are the classes. And you can see that I load up the model here. Here's the sequential. Sequential means do these things in order. I just stole a MobileNet model, added the activation function that I talked about. Here is another W transpose X times B, which gets this, and then we do the softmax. Here is the loss function. We're using binary. I probably should have used binary cross entropy. It probably would have been better, but here I'm using cross entropy. And you're probably wondering, well, how did you went from mean squared error, which was the h of x minus y squared. There are other loss functions that measure suckiness, and you need to use the right one for the right problem. And then here is SGD, which stands for stochastic gradient descent, which is basically the Mario, like jumping around to the bottom of the pit, right? And here's the trained model, right? And when I go to it, let me go to the definition here. You can see basically I'm just doing a loop where I optimize everything. I zero the gradients, right? If we're training, right, I run the model function, I figure out the loss, and then I do the backward step, which finds the gradient, and then I step. And I do this over and over and over and over until it solves the actual problem, and then you get this. Okay, so I went super fast through like a lot of maths and a lot of neural network stuff. But the fundamental thing to understand is that there are 3 things that are happening. You have to construct a model function. Notice that we decided to use MobileNet, which looks like this, right? We started earlier with just a general like W transpose X plus B. Notice that we can start to stack them with functions in between, and then you can start to do more. And then these things get bigger and bigger and bigger. But I want to be completely transparent and tell you that these things are not self-aware. They have no idea what's going on. They are basically, it's like a rock, right, that humans drew smiley faces on that make it look like it thinks it is. Because right now we think, wow, it has like a really funny joke. It thinks that a pizza is a burrito. No, it doesn't think anything. All it did is it multiplied all these pixels by certain numbers, ran functions over them, and did it deeply until it got to an answer at the bottom. And so that's why I don't like when we anthropomorphize AI, because what it does is it shifts the responsibility of ethics from the humans to the model. The model has no sentient ability at all when it comes to AGI, which is generalized artificial intelligence. We are nowhere near anywhere like that, and that's where I think a lot of the ethical issues come on. Because if someone ever tells you, well, that's what the model predicted, you should say, hold on, wait a minute, are you giving the model a pizza when it can only detect tacos and burritos? One question. Another question, what kind of pictures did you use? Did you use actual burritos, or did you use pictures of literal burritos, which I, in fact, did when I trained it? Let me go up to this. Like, I literally used a real burrito when I trained it, right? That's funny, but still. And so that's where the ethical questions, I think, lie for me. When it comes to building, for example, computer vision models, you are effectively using multivariable differential calculus to iteratively create the best possible numbers, weights, and biases in order to optimize the loss function. That's it. And you're probably, well, what about the huge models that actually generate stuff? It's the same thing, except we're using, for example, for generative models like generative adversarial networks, they're basically two networks that are fighting against each other to generate more stuff. Or, for example, for generative models, the transpose of the convolution will generate images for you, but it's still using optimization to figure out the loss between the actual pictures and the ones that are generated. It's still all just math. There's no magicalness at all. And by the way, this code is available. You can go look at it. Let me bring it over here so you can find it. So github.com. I think it's the one that I was showing you that has the explanations is deep learning with PyTorch. So let me bring that over here so you can see that. So those kernels, right, that I was running, and those things that show you like the actual execution graph, those are all there. And then you can look at the tacos versus burritos. If you go to food AI, right, you're going to find all of that code right there. So that code that I just showed you is right here, right? I am making some changes. So you can see on the dev branch, I'm trying to organize things a little bit better. And so that's what you actually saw my code doing. Well, I haven't checked it in yet. Oh, I need to go to dev, sorry. So you can see that I'm starting to make it a little bit more sensible, right? And then add more explanations, but it's all there. There is the food AI and then deep learning with PyTorch. Okay. Whew. Let's go to the questions because I went super fast. Let me turn here. Okay. How easy is it? Okay, no, I need to scroll down. Okay. Any questions so far?
Wow. You should definitely take a breather. That's like
Yeah, I know.
4 years of maths in 30 minutes. That's amazing.
Yeah.
I definitely was having flashbacks to college. So thank you, Seth.
Yes.
that
But
was a
Seth,
lot of
one
math
question.
during the 3 o'clock hour for me.
Oh man, yeah. A huge
Sorry,
flashback
there's no
to
questions.
school.
Everyone's like sitting on the floor. Like, by the way, if you see me turning my head, I'm looking in the chat. No questions. Holy cow! Maybe
You
I'm
did an
such a
awesome
good
job.
explainer of these things that everyone's like, "We totally get it, Seth."
Well, so it was kind of interesting how you kind of simplified it down to, are you passing a picture of a pizza into your model when you've only trained it to recognize burritos and tacos? So how common is that when people build models? Because it sounds like a very common sense question, but it truly sounds like something that we're doing, because when we look at our data sets are comprised of what we think to be the true positive, but how good are we at actually kind of starting the problem statement off with the correct set of data?
Yeah, I don't know. I mean, it depends, right? Especially when you have a ton of data that's not being looked at. That's a problem. I'll give you an example, and this is a silly one, but there's a book called Weapons of Math Destruction, MATH. Kind of funny, right? Weapons of Math Destruction, where they show statistics. For example, if I were to train a model to tell law enforcement in the United States where to go police, well, statistically and historically, Black Americans have been over-policed. That's just, in certain places, that's just the way it is. So if I were to use that data to produce a neural network model, it would basically just learn that it has to go police Black Americans again, right? Another example, an NLP. When you look at these things, for example, like for similarity of words, or which two words go together, it turns out that historically, for whatever sexist reasons, the term doctor and maleness are related in almost everything we've written up to this point. And so you would find that an NLP model might suggest that a doctor is a male thing versus a female thing, where in reality, a doctor is just a doctor, right? And so you'll see a ton of stuff like that inherently built into the data. And so the reality of the matter is, the first question you should ask before doing any of these things is, number one, are these models affecting? Who will these decisions affect? And number two, how might it affect people unfairly? That's what you should start with. And then you need to go into the data and look at it. And then you need to go into these black box and white box models for responsible explainability that Noelle was talking about, to verify if these things are happening or not. And so that's where it goes. But the reality, again, hopefully you saw, even if you didn't get all of it, because like I said, I went through like a year of grad school for like 20 minutes. You recognize that it's not doing anything other than learning numbers to multiply the input by to get the answers out, right? And it's a lot of numbers and a lot of functions, but it's still just numbers.
Yeah. So speaking of Noelle, maybe she can help us out here. I was wondering, when we talk about deep learning, what would be a good sort of explainer that we can apply to our problem and get a sense of what the neural network is doing in the case of predicting tacos versus burritos, for example?
Yeah, that's a great question, actually. So there's a few different ones that I would recommend. The first one, and actually, I don't know if everyone's going to get the slide deck, but I put a few of these tools in the slide deck. So I don't know how that gets shared, or if people want to just find it on slideshare.net.
Yeah, we can put it on the website if you want. That makes sense.
Yeah, sure. So the first one is Fair Learn is one. And there's a really great GitHub-based tutorial that you can walk through. It gives you a sample model. There's also Interpret ML. Both of those give you the ability to just even grab a baseline of how interpretable your models are, and to identify kind of the level of opaqueness or black boxiness, if you will, of your model.
Yeah, that makes sense. Yeah. We've actually written a lot of stuff about it on our blogs, on Medium. So if people are interested, they can definitely check those out.
I posts, so.
Yeah. I know I spend
I think it's really interesting, but I think also a lot of it comes down to just the conversations that are being had at the beginning of a project, and the support of even engineering management and engineering leadership in pausing. Because at least I've been in Microsoft AI teams and in Amazon AI teams, and in both of those teams, our velocity was so high that we really didn't, it was kind of like, Seth's, message. It was like this fire hose of important things that we were doing and really trying to figure out, okay, when do we stop and ask these questions? And we didn't, honestly. Like during those early days of Alexa, when we were gaining hundreds of thousands of users a day, like we weren't asking those questions. So we are, I mean, they are now, but this is what we're all facing. We don't know if the AI we're building now is the next, you know, Facebook or Alexa or Google search, right? We don't know. So you have to ask these questions in the, you know, as a result of that, that you don't know what you're building in AI. We don't know the full extent of how these technologies will be used. So I just say, make it a habit, do it anyway. I think Seth ended it well. You know, ask the one question. I won't make it about burritos or pizzas, but that's like, ask the question. Make sure you know who you're serving and whether or not these predictions actually serve them. And I think that's the best way to start any project.
And so we've had some discussion about ML ops in one of the previous episodes. What do you think in terms of a good approach to integrating explainers and interpreters into your project? Where would you actually place them in your whole ML ops process?
Yeah, so I actually think they belong in a couple different places because there's different impact zones, I call them, for explainable models. So I have, and I'm trying to think if I have it ready to show you, but if we can vision in our mind's eye an architecture diagram of like a model development process, right? And you think about 5 classic stages of building a model, from data collection through ingestion, training, deployment, right? If we think about it from that perspective, there are opportunities for not just the tools. So you're asking me one question, I'm gonna answer it with both. So one is at the very beginning during data collection, diversity in data collection has to be identified and monitored at the very beginning of that process. What we're now doing, because most of us are dealing with models that have already been trained on some form of data. And so the next phase of that is in the actual model pipeline itself. So I am a huge fan of ML ops, is somewhat of a new term, probably to a lot of people who are listening as well. But building an actual code pipeline for AI, I mean, again, in my early stages of Alexa, we had no pipeline. There was no pipeline. It was just like deploy, like fingers on a keyboard, deploy. And so I was shocked to find, you know, I was like, and I was coming similar to Anthony, I was coming from a like AWS kind of infrastructure, cloud infrastructure kind of role. And I was like, why wouldn't we just deploy this like any other code? And we do have tools that we use to protect the integrity of code. And now we're trying to apply them to things that have always sat in research. So I do think that in the phase of actual model deployment, but also in the phase of model creation, that we can leverage these packages that are now being made readily accessible.
So basically,
you're back, Seth. Do you want to add in?
I didn't hear that. My internet went out, and so
it's terrible.
I know.
It's terrible right now, and half a bunch
haunted.
of this country is in the south are like handling a hurricane, so it's kind of sad.
So what was the question? I missed all the important stuff, and now I get to come in here and be like, oh.
It's good for those who need it. Also repeated.
So in general, you're saying actually, Noel, that machine learning might not be that different from regular software engineering. It does get a lot of profit from having the standard practices of building a coded pipeline to bring it to production. So that includes building,
I think that's the
testing,
distinction, is that specifically around pipelines. Like, why wouldn't we leverage the values that we see in code pipelines in deploying, which we're now seeing in ML ops, but like, why wouldn't we do that? And that now, if we create a pipeline, we have different stages of deploying that pipeline that we can inject interpretability or fairness checkers, if you will, or detectors. And there's lots of different packages that support that across that pipeline.
I'm almost thinking that this is just a different sort of test that you run. Just like you run unit tests on your code.
Yes,
this could be another test, actually.
Yeah, I do think it's soon. So I don't think we've got the maturity in those types of tests and the results that they give. Because right now, the results that come out of a lot of these tests have to be discerned by a human. And then we have to go and fix them. Just like automated ML or some of our automated AI tools, eventually we can use AI to fix the problems that it detects in itself. But we're not there yet, especially in explainability.
Huh.
Yeah, I would add, like Noelle is 1,000% right. We, for some reason, in general, data science is like, because machine learning models are now going into production, it's like 1995 all over again for programmers. Remember in programming, we used to like, oh, we should probably use source control, right? Like right now, Noelle, you know this better than anyone. People are just emailing models around like we used to email code around. And so now we're getting into robust software practice because after all, it's just software. And when it comes to like, here's a simple thing. Maybe you should have some examples of things that it always needs to be non-biased at. Put them in unit tests in the pipeline and say, here's a picture of a pizza and it should guess none, right? Maybe just put that as a unit test as part of the build process. Maybe have images or maybe have examples of things that it should not be doing and have it put it in unit tests and fail it. And that's like a really, really good start. But Noelle is right. The important responsible ML stuff, like FairLearn, for example, the white box models that look inside of decision trees, for example, or the black box models that, as Noelle expertly pointed out, swap features in and out to see like how much does it change. Like here's a simple example. If gender is one of your features and you take it out and all of a sudden it starts predicting differently, or the disparity between genders is huge, you have a problem. You could test that pretty easily, right? And you should. And so I'm 1,000% in agreement with what Noelle is saying.
Yeah. And so we've talked about these pipelines, and this is sort of the quality check going into production. And I'm thinking also, once you are in production, things might change actually. So you might run into problems where maybe the samples in production change from the samples that we've used for training. Is there anything we can do about that actually?
Well,
yeah.
Go ahead, Seth.
No, please, Noelle.
I was just going to say that one thing I always try to encourage organizations is to not think about production in the same way. Like AI is the definition of a perpetual beta. So I don't feel like there's the classic, sense of like pristine production, which again is just a paradigm shift from kind of a software engineering world where we push something in production and it's done. Where an AI model, we were changing, Alexa, and even now at Microsoft and cognitive services, like those models are being updated on the fly. Your decisions in a pre-built model can change the next time you call it. Which if you all remember in the early days of Alexa, you could ask it a question and the very next day ask it the same question and the answer would be different because we were constantly updating it. So I think I always encourage people to remember these are experiments that we are choosing to put in production, and those experiments don't change just due to the nature of their deployment.
Some mathematical things you can do, just to follow on with what Noelle is saying, is you have the original data set you use to train, especially if you have what's called data provenance through your models. So you know what data was used to train it. You should also store the data that you're doing what's called inference on, which is the prediction, right? And what you can do is you can use unsupervised machine learning to actually detect if there is a large difference between the data set you use to train your actual model and the data set that you're actually doing inference on. This is called data drift or sometimes model drift. And you can create a machine learning model that gets the appropriate tolerance for change. Obviously, this is more of a robust scenario. People that have been doing an AI or machine learning for a long time, but you can actually measure the difference in the data sets in using unsupervised learning. For example, you could do on your original data you used to train, you could do k-means and find the centers of the data, right? And then output that into an n-dimensional vector. You could do the same as soon as you start collecting a lot of data into an n-dimensional vector. And then you can measure the distance. And if the distance is super large, you can say, we need to retrain. But as Noelle said, that still never will take away from the human aspect of if the data is biased, even during inference, is still going to have a problem, right? Even if the distance between the unsupervised data, between the unsupervised models, between the data, like the trained data and the inference data, even if the difference is small, you will still miss certain things, especially if your model is still biased, right? And that's a problem that will not be solved with those empirical methods, but it's a check that you could use, I think.
It's a sort of an additional safety net, and we can't have enough of those.
Yeah, both
in this
and
world.
both and do it all.
Yeah, I mean, and this is some of the more advanced stuff. I guess that there's still a lot of people that are getting into the AI space and trying to make sense of everything that they need to do. And this sounds like a lot of work, actually, if I'm honest. So I'm thinking, what would be actually the first thing that you would do, Noel, when talking about improving the ethical side of AI?
Well, if we're talking about beginners, I'm always telling you, I tell CEOs that are like investing in AI for the first time, you have to have a strategy. We call it like an AI manifesto. You have to have a decision, and you need to align ethical use of this technology with your business values, because your business, meaning those who are going to come to the models and say, I have this problem and I need it solved, are going to be incented in certain ways. And that incentive needs to include ethical and responsible use of this technology. So I always encourage people that they need to have the backing of those asking the question, because usually as a modeler, we're not solving our own problems. We're solving a problem that's been presented to us. So we need to make sure that we have executive support or even just managerial support for pulling the chain on the train and stopping or pausing or asking different questions if our model starts to behave badly. The other thing I would say, and I'll only say two things, is that also making the decision to leverage at the very least a fairness package, a simple line of code that you would execute upon testing your model, just to say, like, here's how these here's how the confidence is performing against our baseline, or here's how, do something. I even ask the question, force everybody who does something with their model to explain every decision that they make in a stand-up. It doesn't have to be hard. It doesn't have to even be in code, but it does have to be model driven.
Oh, that's interesting.
Yeah, I would add.
Yeah.
I would also add a simple test. Like, maybe we should, as a society, decide that we need to add a disclaimer and say this decision has been aided by mechanical means. Right? Just knowing. Like, I was talking to somebody in a smaller country, and they were trying to come up with some good AI-based laws that they might come up. I'm like, hey, look, a simple one is just say this decision was partly aided by mechanical methods. Right away, you can start to think about the ethical implications of these things, right? Was I denied alone because their model is bad, or because a human looked at it, right? Both can still be problems, right? But at least there's some disclosure going on there. But yeah, like Noel said, a single test is easy to do. And if you, as a company, have an ethos that you do not want to discriminate based on gender, nationality, color, whatever, maybe you should put those in as tests for your model. Just as simple, like invent a person and make it so that it's exactly the thing that you do not want to discriminate. Put it in as a single line of code. It's not hard to do. It's a unit test for fairness, and you might find that your model is still unfair. Add another unit test, right? But like Noel said, there's with a tiny bit of effort, one line, you can start to test a lot of things like that.
Yeah, it sounds. I mean, thinking about it in my own projects, it doesn't sound all that complicated to actually include a few extra unit tests down the line and perform a few extra steps. Those are small enough to be done in seconds, actually, in most build pipelines. So Those are
Yeah, and
actually,
especially once you do it once, right? Like all you have to do is ask the question one time, build one test, and it can scale across your whole organization. The problem is oftentimes, just like with those of us who have been in software engineering teams that were hesitant to test, building the test is actually, it could be hard. It could take a while to figure out who is that person, but it's worth the investment because it's a one-time investment. And then, and as all of us who are test-driven developers know, once you build successfully against a test, you never really want to build any other way. Like it cleans up your code, you get 100% code coverage, like all sorts of good things come out of it. And so, yeah, there's a little bit of an investment. It will be not a lot of code, but understanding what code to write is going to take some questions. But
Uh-oh.
sound is gone. Uh-oh.
Can y'all hear me?
Yes, that's the one.
I'm sorry. I'm here. Sorry about that.
No problem.
I accidentally muted myself.
Oh.
Oh.
Self-mutation.
Yeah, and I'll just simply add to what Noelle is saying. Basically, machine learning models are just functions that were lazily written with data. So if you think of a model as a function, anything programmers can do with functions, you can do with models once they've been created. You can unit test them. You can email them to, like I literally showed you. The one I showed you is literally like a model.onnx. It's a file, and I clicked on it, opened it in Netron. You can see the innards of it. There was no rainbows and butterflies in there. It was just a bunch of numbers. It was kind of boring, actually.
Friends email models.
Yeah, I know.
Yeah,
I know.
exactly.
People do that stuff.
So, Alicia, how is that in your work? How do you approach this sort of stuff in your team?
Yeah, so we do find that there is a kind of like a growth cycle with data science teams. So, depending on the maturity of the data science team and the size of the organization, but definitely part of the infrastructure that we do put in place at a lot of our customer sites is the ML Maps for their data science projects. So, and this is part of making the process repeatable and having faith in the recommendations coming out of the experiments. So, yes, their base function testing is much needed for many of these projects, and I do see to this day huge organizations who have data scientists who write their code on their laptop, and they're the only ones with access to the experiments. So I'm a very strong supporter for ML ops in the data science space.
And come to think of it, so I've got a lot of data scientists that I work with on teams. And one of the things that we started doing actually at InfoSupport is we know that there's two kinds of data scientists in the world, roughly. There's the A type, the analytical persons who are really good at data analysis, but not so good at building models using software engineering practices. The focus has been more on data analysis there. The other type of data scientist that I encounter in a while is the person, it's a B type, a builder, if you will. The person that's actually coming from a software engineering background and thinking in terms of, I need to test this, I need to focus on a unit test first and then write my model. We actually started sort of selecting towards this B type and teaching people all these software engineering skills, because that turns out to be very important to not only get people that are writing neat code, because we've seen some pretty interesting Python notebooks producing models. That's sort of a big no in production. But also getting people into the mindset of testing first, writing a test first, and then writing the code to actually generate this model instead of the other way around. It's really been helpful. So, and Noelle, have you seen this also in other companies actually that you've worked with?
Yeah, well, it's definitely a tendency or a direction I'm encouraging organizations to go in, mainly because I actually we have data scientists, and a lot of them were sitting in an R&D type team. And so productizing an R&D team is not necessarily the right thing to do for every organization. Oftentimes, I like to see that R&D team do their thing, keep researching, and then they deploy their model, and it's handed to what I have now created, AI engineers, right? Those builders that understand machine learning, that are classically trained, if you will, but that are more software engineering focused. They are the ones that build and use the code pipelines. They're the ones who manage change in production. And so I do have that same separation, and I've seen it work well. But I also know very large companies like Microsoft and Amazon have taken their R&D teams and just picked them up and dropped them into productized organizations. And that seems to be working okay too. So so I think there's probably benefits to both, but definitely understanding that there's so much that we can learn from both sides, the analytical mind. And I actually at HackerU, I have a full stack development team and a data science team, and they think completely differently. But that diversity of thought creates much better outcomes. And I think that that's probably the moral of the story from my perspective.
Yeah, that makes sense. So there's not actually one shape of data scientist or one type of team that's going to get you across the finish line. There's it's important to keep this mindset regardless of what you have in your company. We need to make sure that people understand that it starts with asking the right questions to your model. Here.
Yep, I agree.
Cool.
Yeah, it should always start with a sharp question. What is it no one would ever be like, oh, I need to write a function today. Just like people are like, oh, I need to make some AI today. No, it's the same thing. You don't write functions for no reason. And a lot of people right now are running around with a hammer, which is the ML machine learning hammer, and they're like, what should I hit with it? And they're trying to hit screws in with a hammer. Sure, you'll get it to go in, but you're going to break some stuff, right? And maybe machine learning isn't the right approach, but you should always start with a sharp question, right? Are we trying to predict between classes? Are we trying to get a continuous value? Do we even have a value that we want to come out with? And it should start with a business question. And the reality of the matter is the people that are successfully using machine learning don't talk about it that much, because if they were to tell me, hey, Seth, I made a machine learning model that did foo, I would almost immediately know how they built it. Almost. Pretty close, right? And so the people that are using it well have an understanding that there's a business need for it, have an understanding that there's responsibility behind using it, and they probably have some engineering practices behind it. So if you want to get to that point, it's all programmer stuff. Everyone knows. All programmers know how to do this kind of thing.
Huh. That's pretty cool. I mean,
yeah, and it's kind of nice because it allows us to open up opportunities for reskilling our staff, right? I know some of us in the data science world, the longer we've been in it, the more pristine that environment and echo chambery that environment is. But the reality is now, Anthony was a great example. The reality is now people who have a problem, if they're technically inclined, we have technology that allows them to solve that problem, or at least build the POC so that they can articulate that problem in the most accurate way to a modeler. And so I feel really closing that gap between the business user and the technologist that's going to solve it is something that we're seeing, at least in my career over the last 20 years. I've never seen it be as possible and successful as I do today, now that we've got these kind of democratized models and ability for people to use a web browser to train a model. They don't have to train the model, but they can at least give me the right idea as my team actually builds it. So I think that's unique and something we can be grateful for.
Yeah, certainly, yeah. So actually what you're saying is, don't worry so much about the fact that a data scientist has formal education in statistics and all the maths that you need to build a model from scratch. Worry about the fact that you know as a software engineer maybe about the business that your customer is in, and then start working with the democratized tools that we have, such as cognitive services, and at least get started. That's really cool. It breaks down the gates to this amazing technology that we as a community have been talking about for years now. That's really cool to hear that from you. So
yeah, not all of us can talk like Seth. So,
He's pretty fast
and
with all the
if
maths.
we put all of the burden on people like Seth to solve all of the problems, like we wouldn't get there. We can't get there. So we have to figure out a way to get at least started. Like just get your problem, get it like modeled in a democratized model so that someone like, you know, an engineering team, a model engineering team can look at it and go, I see what you're trying to do there. Okay, I can work with this. As opposed to right now, you know, one side says something and the other side hears something totally different. But now we've got tools and technologies that really bridge that gap. And I'm trying, you know, that's what I do now is I go talk to as many companies who will hear me to tell them, like, you don't have to wait for your data scientists to show up. Like, you can start right now. You can do this right now with your web developers and software engineers. They can do quite a bit to get you going. And then, you know, as you invest and as you find the data scientists to help you finish the deal, the job.
So I've got
And I am not a research caliber data guy, FYI. I'm not. I just like the math, right? And so I like understanding how things.
Liking math is enough.
I just like how it works. Like internally, like once you know how it works, it's quite impressive that it's actually doing anything reasonable, which is to me super surprising. And so I wouldn't consider myself to be on the avant-garde. I actually interviewed people that are. Like I've interviewed Turing Award winners that have done deep learning for a living in research, and they too say stuff like, you know, it's still kind of squishy. Like for example, with earlier machine learning models, you could actually use standard mathematical approaches to understand how good they are. You can't do that with deep learning at all right now. There's no mathematical framework for them for us to predict those kinds of things, which is telling.
Yeah, I think the whole approach between the neat people and the scruffy people, I remember that from the first episode. We had a conversation with Richard about that. Yeah, right now we're in a episode where we can see that the scruffy people have the upper hand. And it feels to me that things like explainers and interpreters are more important than ever, actually, to make sense of all the stuff that they are doing. So thank you very much, both of you. We're full out of time. This is going so fast. So if people want to continue the conversation, please do so in our live chat. It will be active after the show as well. Let me quickly look up, because we've got a winner for our prize. If my computer wants to cooperate. So, Vladimir, you're the lucky person today. You won the $50 Amazon gift card. We're making sure that you get that. And Alicia, do you have any final thoughts? We're at the end of the episode, so what do you think?
This has been a fantastic set of sessions, and thank you to all of our speakers. I'm amazed every time the global AI community puts on an event, and the quality of speakers and the passion, and I'm so grateful to be part of the Microsoft community. And I'm definitely looking forward to February with Global AI Boot Camps.
Absolutely.
So thank you for including us.
Yeah, you're welcome. And I too have to thank all the speakers, everyone who's joined us and spent time talking to us, coming up with interview questions, with ideas for sessions, and checking out all the technical stuff. I have to say, nobody's seen Hank in the episodes, but Hank is behind the scenes. He's right here in the studio. He's doing all the technical stuff for us, pushing buttons, making sure that the sound is working, failing video connections, just like we had tonight with Seth. That's amazing too. That's really important stuff that needs to be done. And I know how many hours he spent on getting this all to work for us. And finally, I'd like to thank our sponsors as well. Microsoft have been very grateful to give us the money to make this all possible. They've helped us in many, many ways. Speakers, also contacts in the field. My own employer, your employer, Alicia, for giving us time to do this actually during our work days. That's not possible for everyone, and I'm especially grateful that we can do that to offer the community the best possible content. At least I think we've spent a lot of time and effort to do this, and I hope people like it. Yeah, a huge thank you for everyone watching. We've had so many reactions. I mean, it's unbelievable how many people have asked us questions and sent us comments afterwards, thanking us. So I'm happy, and with that, yeah, this is the last episode of the October sessions. So we'll be gone for a little bit for Christmas time possibly, but we'll be back. So we have Global AI bootcamps in January, February. People can join those. Those are locally organized by a lot of people across the globe. I know there's 100+ locations, so that's a lot of places where you can go to learn more about AI. And I'm especially looking forward to people trying things out. For example, building your own custom computer vision model, maybe trying out PyTorch. Please let us know on Twitter, to our usual channels. Send us a message and show us your stuff that you're working on. I'm certainly curious, and if anybody has anything interesting to tell us, I'm sure Sami, who's been here on the episode as well, is happy to have them on the Global AI Talks, which is a weekly show that we run on Thursday also, which will continue next week, and pick up all the stories that we've been talking about with other speakers in the field. So yeah, thank you very much, Alicia, for joining us. How's the puppy doing?
Oh, I think he's napping right now.
Oh, so happy.
Thankfully.
Can I still adopt him?
Absolutely. You know what? I will stick him in my suitcase when I come visit you.
Oh, yeah. That would be awesome. Well, thank you very much. Everyone, have a nice afternoon, morning, evening, wherever you are, and stay safe, and we'll see you soon.
Yes. Please, everyone, be safe.
See ya.
See ya.